get started up here. And we're going to start off today working on the sound effects a little bit. Before we get into work on capturing the fireball, we need to work on tweaking the fireball further as well. Just kind of give you a sense of where we are on that. Let's get that up and do this. See what we are as of yesterday. Right here. There. So we have a little bit of that, not bad. We also have throws. We have a little bit of throws on here. We're going to throw it. And there's some, there's some bugs here. I just sort of wrote this, but it's not bad. Am I muted? No, I'm muted. Design Patterns, thanks so much. Let's start again. Thanks so much, Design Patterns. Sometimes, I didn't get a lot of sleep last night, so the brain is not functioning as well as I wanted to. All right, so here one more time. There we go. There. Bring it back. And turn my hand around. If I do it slowly enough, it won't think it's a throw. It's too little sensitive on the throw. We'll get it. The music in Windows is overpowering you. Check, check, check. All right, let's fix that. Let's drop that down a bit. All right. How is that? That's probably sounding a little better. Much, much better. Okay, cool. One more time. There we go. Yeah, the turns aren't working so well because it's sensing a throw, but it's essentially drawing on the back plane if my hand is facing backwards. And then drawing on the front plane. Here we go. If it's facing forward, and as I get closer to the camera, it gets bigger. As I get further away from the camera, it gets smaller. It's also hovering up. It's kind of in a three-dimensional place above my the palm of my hand. So here we go. Move it over there. It totally destroys the illusion there, doesn't it? Here we go. If I lean my hand forward enough, it'll put on the forward plane there. We can see it. So we kind of maybe need to, play with this, make it a little more intelligent. Right now it looks kind of almost laughable. There we go. But with like a little bit of practice in terms of what I do with my hands. And that jump is sudden right there, right? It's almost like I have to turn my hand quickly, but then it thinks it's a throw. Anyway, that's where we are. What I want to do today, the first thing I want to do today is I want to get in and, over here, Fireball, why are you over there? I think it's got my other hand. There we go. All right. What I want to do today is as I want to add sound. And as I move the Fireball closer to the camera, I want the sound to increase in volume. That's what I want to do. And as I move it farther away, I want it to get quieter. That's what I want it to do. So that's kind of what we're looking at. There's a throw. Yeah, so let's look at that. I was up in the drone game looking over at the boombox. The boombox is what we use. The boombox is behind Fred. I think I'm going to take me out for a second. You can see the boombox over there in the corner over there behind Fred. That boombox has tied its fade in and fade out sound. The way we implemented that is we create a new boombox when we want to fade a song in. We fade the old boombox out, and since we had this fading code already working well, I just tied the volume multiplier by the alpha, and I kind of rounded it to a few digits here. So basically multiplying by 10 and then dividing by 10 should give us like a 1 decimal point kind of number. So that's what I want to do. Set volume for active song. Comes in here, figures out what the volume property is, takes the, kind of does some conversion of that, and then multiplies by the fade multiplier on that. So there's essentially a kind of a fade out, fade in. The reason this is important is because the sound that I have for the Fireball close and the Fireball far sounds, both of these sounds, here I'll open them up so we can listen to them. Both of these sounds are static in terms of their length. They're only like, what's this one? This one's actually not bad. It's 1 minute and 20 seconds long, so it's not bad. But I want to be able to loop it. And I found in the past that as soon as this stops, if I immediately start it back up, there's a gap in the loop. You know, with 1 minute and 20 though, am I really going to hold that up for more than 1 minute and 20 at any time? Probably not. I could actually maybe get away with not looping it and just restarting it when I have a new one. So that's the sound effect. Right there. And we can adjust the volume up and down. So that's Fireball close, Fireball far. How's that sound? Right? So the idea is I maybe have both the sounds playing, and whichever one is closest, or if the Fireball gets close, I amplify the volume of the Fireball close and I drop the volume of the Fireball far. So that's that. In order to set the volume, I need to get the active song. To get the active song, all I need to do is just call Safe Play MP3 Return Audio. And that should be good. The getting this event listener in here, wow, that goes crazy, doesn't it? I almost want a link at this point. Give me a link. The add event listener, the only purpose of that is to get the duration so we can fade in, fade out. I think I've decided I'm not going to crossfade this. I'm going to basically, this has got how long is the far one? It's about 1 minute. So yeah, so I've got about 1 minute to play before, we end it. And I think I'm going to run with that. And we'll see how that goes. Okay. So with that, I need to put sound somewhere. And I don't actually want to put it in both the front and the back game. I want to put it in only one of those two locations. Or maybe I put the front sound in the front game and the back sound in the back game. And I independently work them both, putting shared code in Dragon Game, the Ancestor class. I think I'm going to do that instead. That's what I'm going to do. So let's see if we can figure out where we are first putting our Fireball. Let me clean this up. I like to clean these up when I see these. Hey, Pudding. Why clean it if it's going to get dirty again? Fastest gun in the Deep South. All right. So let's see. Well, let's go find our Fireball. Really no more Fireball? Did I really put it all in Dragon Game? I guess I did. Okay. So in Dragon Game, This is where we launch it from. We launch it from this sprite right here. Add scaled sprite. That's where we launch the fireball, I think, right there. All right, so in that case, I want to say this dot add fireball sound is what I think I want to do. Let's try that. And let's go over to our drone game where we're looking at that code. We want something kind of like this. We want we're going to need a sound manager. All right, let's create that first. Hey, look who's there! Hey, watch out for that! Oh, that was a close one, wasn't it? Whoa! Oh, man! Help me! Hey, Frackberg. Let's see if we can miss the iceberg this time. Never misses! Okay, sound manager. I think it's just a sound manager. I think I just got two of these here. Let's rename this to the Leap Effect Sound Manager. Hey, I already took a shower, man. Come on. Oh, look right there. Hey, Copper Beardy.
Copper Beardy is in the house.
Welcome. All right, so I got my Leap Effect Sound Manager here. I'm not going to create it, I think. Or am I? I think maybe I can create it here, actually. This is the ancestor class. There'll be two different instances that will be created. Let's do that. Where's our constructor? I like to have my constructor near the front, near the top of the file, but I'm not seeing that. What's the fastest way to find this? Wait, if I come over here to Dragon Game, see, can I do a Shift F12 here? Find references. One of these will be my constructor, right? No. I'm just tabbing the next reference, trying to find a new on this so I can jump in, because I'm like totally blanking out on what the constructor, what I can even search for here to find the constructor. I feel like it's constructor is what I feel like it is. There we go. Let's go dive into that. It is constructor. Okay. Is that it? That's my Dragon Game constructor right there. So I'm going to say this dot leap effect sound manager is equal to new sound manager. Should be okay. Maybe not. Sound path. Well, look, we got one right down here. Okay. So there's my Leap Effect Sound Manager, and it's being initialized correctly. Let's put this down here under Shared Sound so we've got these both together. Okay. The Fireball, add Fireball sound. Here's where I want to start differentiating what the properties are here between the two different descendant classes. I think I'm going to say this dot Fireball sound. This is some compare threshold. We don't need that at all. Yasmin Indusa says hi. Welcome, Yasmin Indusa. I'm thinking about having a property here and then initializing it in the constructor, whatever the sound file is. Now let's just do that. And then in our descendants, Dragon Front game, and that one is going to be Fireball Close in the front game. And in my Dragon Back game, it's going to be equal to Fireball Far. Yasmin says, I'm not here very often. Maybe you can quickly bring me up to speed on what you're making. Also, who is the blue guy? The blue guy is Fred. Fred, say hi. That's Fred. I am working on right now the Leap. I'm working with the Leap motion detector right here. And this essentially uses a couple of infrared cameras to get three-dimensional data in space of skeletal data from my hands. I'm using that to combined with some math and some overlay visual effects to, let's see if we can make this work here. Give you a demo of this. Let me move this off the side. Let's bring this over here, actually, different monitor. I'm using it to be able to, eventually I want to be able to throw fireballs from my hands. I want to be able to come up here, get a fireball in, and then it's like, for example, I move my hand backwards, the fireball tracks my hand and it scales as well. And I can even throw it, right, a little bit there. So if I push it forward, I can throw it. I can even throw it up and it should be able to come back down. I don't have the ability to catch it yet, but I want to add that as well. So that's kind of what we're looking at, this ability to kind of get a fireball in there, make it look and sound close to real. Right now it's a little more on the side of comical than it is real. But there is, there's some cool stuff going on here. For example, one, if I lift my hand up, you can see it floats kind of above my hand. Well, so yeah, comical, as I said. The reason that happened is because the leap is here, and from its perspective, I'm blocking my fingers, so it can't actually see my fingers very well if I hold my hand in that direction. But if I flip it around like this, and I do it like that, there you can see it. And you can see how it's kind of behind my fingertips right there. But I can also turn my hand around like this, and it's now, well, it's now in front of my fingertips. So we're just kind of getting that from comical to maybe looking good. That's what we're trying to do. We're working in C# and in TypeScript. Right now we're in TypeScript, and we're writing code to play the fireball sound, make it louder as I bring it closer and quieter as I move it farther away. So when I'm back over here, It'll be not so much. What's that? Why isn't that even moving one? That one's not even moving. There we go. The fireball is used for what? What's the fireball for? Well, we've got a show. Oops, I got to keep my hand back in here. We've got a show out here on Twitch, which I'll give you a link to right here. It's Dungeons and Dragons. And so I am playing with this technology right now. It's kind of like an R&D stage, but I'm playing with it for consideration to include it in the show. For example, to cast fireball effects, or to come in and be able to, do something like this. Here, can I do it? Well, that guy's coming in. Get some. There we go. Like that. To be able to say I'm going to cast a spell like this, and kind of, wherever my hand is, right? It just kind of does that, right? And follows my hand wherever it is, right? So I can do that kind of a spell effect. That's what I'm trying to do. So, we'll see if we get it to work or not. There's certain parts of it that are not bad, right? These kinds of effects here. Let's see, is this working? There we go. These kinds of effects are kind of cool, right? And I can combine them together. I can combine multiple ones together and kind of do that. Very, very advanced game manager and special effects. Yeah, I should point that out as well. Right. In addition to all of that, we've also got die rolls and special effects. For example, what can we do here that's fun to show? Let's see if the ice storm works. All right, so there's the ice storm spell. There's the effects in front of the player. Got cold damage, bludgeoning damage.
Bludgeoning damage. Plus 16 cold damage.
You got that there. The spell is kind of blocked out by the camera on the keyboard, but that's kind of what we're looking at there. We've kind of created these different spell pages right over here. Hey, baby, how you doing? Yeah, I'm good. Your phone was not charging when I came in, so I kind of moved it off to the side, so it may not be fully charged. All right. So that's kind of what we're doing a little bit. Right now we're working on the leap motion tracking, trying to get the sound effect to come with it, see how it looks. We're going to see, what it takes to make it look really, really good and really solid, if we can get it there. Who knows? But right now we're working on sound. All right, Yasmin. All right, Yasmin says, that's awesome. It's not bad. There's some cool stuff, definitely cool stuff here. I feel compelled to also show you this part too. So for example, if I need to roll a saving throw, this comes up and I can give myself advantage, right, like that. So I've got advantage on it. And maybe a skill check instead. So I'll do like an investigation check. And there's my advantage roll coming out there as well. And anyway, that's kind of what it looks like right there. So that's about it. Okay. Clear the dice up. And so my fireball sound is going to be fireball far. It's my wild magic check die roll automatically coming in there. Let's close that scroll again. So this is going to be fireball far. And actually, we kind of need to go further than this. We need to go into leap effects. It's kind of what we need to do somewhere. I think I'm going to do this. I'm going to put this all the way to here. So then I just need to do so this is the Leap Effect Sound Manager. It's going to use the Leap Effect folder, and I'm going to grab the Fireball sound right there. And that's how I'm going to play it. That's in the Ancestor class and Dragon game. So Fred, is he like a bot, or is he a real person behind that avatar? No, he's just a bot. kind of, but you know, I can point to him, and he can point back to me. He can wave, and you know, he can answer basic questions like, you know, what should we do next, Fred? Okay, something along those lines. So basically, there are different buttons that are out there. Jetsam just typed in test wave to make him wave, that sort of thing. So we just basically, he just sits and watches us. But he's also a player in the game. So Fred is actually a player in the game. So actually, if you watch the other show, Fred will, you know, have different moves. Like he'll come in and he'll say, I want to use my great axe like that and run his attack. And his great axe comes in with slashing damage. And that's
15 plus 8 hits with 12 slashing damage.
good job, Fred. Like that. So anyway, that's it. Yeah, it's kind of like basically if you know, what would it kind of answers the question? What would it look like if ESPN covered Dungeons and Dragons? That's kind of what we're talking about here. So we're trying to create over-the-top special effects for the show, and that's what we're doing. All right. So Leap Fireball sound, the safe play return audio. What does that return? An HTML audio element. Okay. So we're going to have the active Leap Fireball sound be here. And then we're going to maintain this its volume based on the distance. Just thinking about if I should rename this or not. So I think that's kind of all we need there. We've got add fireball sound is here. We're not playing it though. No, we are. We're playing it right there. Okay. So next we need to now, you know, adjust volume. At the very least, we need to turn it off when we get rid of the fireball. So let's go look at when we kill all the fireballs. Here's where we do it. How do we stop playing a song? There's a pause. We can do that at the very least. Is there another place where this thing is cleared? If there is, I should turn it into a method. I should probably turn it into a method anyway. Kill hand effects. This is what I should really be calling right here. What does it need? Kill follow effects. Oh, maybe I don't want that. Hold on. Let's get close to this. Let's create a new function. It's going to be destroy fireballs. Destroy all fireballs. Like that. From here, I'm going to call destroy all fireballs. Like this. And then jump back to where I was. I'm going to call it that instead. Destroy all fireballs. Okay. So that's going to kill the sound as well. So right now the sound, we should hear the sound. It should go on and off at the same time. It might be a little loud, but let's try that. Let's refresh. I'm going to refresh only the front overlay, I think. And let's get the keyboard camera back on again, so you can see that. All right. Fireball. Oh, I forgot. I got to give that window focus to get the leap data. Okay. And then, nice. All right, I'm going to call that working. Next, we need to adjust its volume based on how close it is to the camera. All right, let's take a look at that. All right. I almost think there's got to be a stop in here. Why isn't there a stop? All right, let's do a search on this, figure out what we're missing. Yeah, I noticed that too. You call pause. All right. So I guess all right, I think I'm going to do this. Like that. That's kind of what I've basically been struggling with. Should I set it to null or not at the end? And I think I'm going to do that. Uh-oh. I hold my breath every time that comes up. How you doing, Deepwater? Deepwater with the understated fanfare coming in. Jetsam hasn't had lunch yet. Glad you guys are with us. Okay. Active leap fireball sound. This is what I want to crank the volume up or down depending on how far it is away. So that's going to be in a method out here that we're calling update something. Update tracking effects is here. Here though, okay, I just realized I got a logic problem here. This gets the hand from the skeletal data. If I throw the ball in the air and then bring my hands down, no more hands come down. There's no more hands coming down here. So this could be empty and we just get out, which means we're not going to update the sound effects for the fireball. So if I throw the fireball at the camera and then bring my hand down, we're not going to be able to adjust the volume as it approaches. So what I want to do instead of this getting out is I want to come in here is I want to say if showing hand speed and hand like that, then let's go else and see where else we're working with this. Or I'm going to say hand and that. I'm not sure about the, yeah, it should be the same priority. It should prioritize this over that. I'm going to throw an extra paren around it anyway though, just in case. So we don't have a bug there that is okay. And then if thrown, are we on the front canvas? If hand, then we're on the front canvas in this scenario. Else, I want to say something like if thrown object position Z. Now, what point are we going to say we're in the front plane? It's about here, which if I'm recalling correctly, is about 270, I think. Negative 270, I mean. Wonder if we can get that from the Leap diagnostics. Let's see if we can do that so we don't have to... All right. Do I have... Oh, I guess I'm not going to really get the coordinates here, will I? Yeah, it's really... The leap is really best from like here to here. It's almost as if I should move this whole thing back. Can I get a stable hand there? I really can, it looks like. It's a little jumpy. Yeah, the problem was I'm like here and I'm starting to move back and I'm losing my stability on the hand. I'm getting back here and it's like starting to jump all over the place. I was hoping to get the X and Y position, but that's not showing up here. Let's do it as diagnostics, and we'll figure out what that is. Write some code to see what that Z is. There's some magic point. So if the thrown position Z, I kind of want to come in here and say mid-plane Z, and I'm guessing it's like negative 200. Is what I think it is, but we're going to do this. And then we're going to come down here and say, hey, if the position C is less than the midplane Z, so Z gets bigger as I move in this direction towards the camera, right? That direction, as I recall. So if it is less than that, then we are on the front canvas. And otherwise we are... we're just going to do this, actually. Okay, then we get rid of this. Okay, so if it's thrown, if the hand exists, we're checking to see for the front canvas if the Z is greater than the throwing hand position. That's what we're going to draw in front of the hand. Otherwise, we're going to compare it to just this mid-plane Z constant, which we're going to need to figure out. Okay, to do that, we're going to need to show position Z, what that is. Excuse me, and to do that, do I have a method in here with the word diagnostic in it? Nope. Let's see, tracking, really nothing. It's somewhere near this space here. Show hand speed. All right, I think what I want to do is yeah, showing hand speed. I want to set that to false. That draws these bars on the side that show the relative hand speed. That was useful when we were detecting throws. But I think what I want to do is I'm looking for a diagnostics method. I thought we had a method with the word diagnostics in it. All right, let's do this. Let's look for an arc. Show live hand position. Okay, help me find this better next time. Show diagnostics, live hand position. All right, so in the live hand position, we're sending what the direction of the palm is. We're putting that out to it. And I think what I want to do is do another one here, and we're going to say here, we're going to say our the Z value, whatever that is. Palm position dot shoot, I've got scale. That's not what I want. Hand dot position Z. That's what I want. So position Z dot to string. Can I? I'm looking for a. I'm not sure what radix is. I'm looking for a number of digits to limit this to, because I think it's going to get long and unwieldy to read. Is what I think it's going to do. This is going to come down. I'm going to put this down below the other one by about 32, which is the same as the font size right here. Well, actually, that's not entirely true. It's this times the scale. So let's do this. Let's create a new constant font size like this. Put that down there. And then we're going to drop it down by the font size. So now we're going to see what the number is right there. Let's refresh the show diagnostics live hand position. That's only called in the Dragon front game, it looks like. Cool. All right, cool. So we're going to refresh the front game, the front overlay. Design Patterns is asking 270. What did I miss on that, Design Patterns? 270. All right. Let's show live hand position, get our data. Okay, here's the number. What? How is the Z plane not essentially changing at all? The Z position. What? That's totally unexpected. Based on what I believe that is supposed to be. Basically talking about 0.8 something to point whatever. All right, let's do this. Math dot round of this times 10 divided by 10. How's that? Refresh. Magic Max for Z, I think. Also very popular number this week. I thought it was, well, maybe I said that. I'm not sure. It was around 220 is what I remember it being, but this is so far off from that. All right, let's refresh. Refresh. There's my data. Yeah, this doesn't make any sense at all to me. Why is that position Z so low? What am I missing here? I think I'm missing some sort of foundational understanding. I'm going to switch over to the C# app, because that's where we're sending that data. Well, we're calling set palm properties whenever we create a new hand, and I think we're creating a new hand every time we get a new frame in. All right. Doesn't make sense to me. I thought before when I was showing these numbers, they were really much bigger. I wonder if the Z is different from how I understand it to be. Let's do this. Let's give it a few more digits. Let's give it one more digit at least of precision. Is it factored in some respect? Yeah, I'm really not sure. But it's looking a little bit weird and different to me than I'm expecting. Okay. So 9.9. Yeah, it's jumping all over the place. Yeah, it's all over the place. Look at this. It depends on where I'm turning. I think the position Z is relative to my palm. I think that's what's going on. That's not good, because we've been using that data to make decisions. That's not good. Let's jump over here into this space. Where was that position Z? Palm normal dot Z. All right. Leap motion. Palm normal to world coordinates. All right, let's scale factor. That's kind of cool. So if I move my fingers out, scale factor will be greater than 1. That's kind of cool to know. All right. Yeah, I'm super confused by this. Yeah, I'm gonna even set a breakpoint here and see if I can get it to stop here. We have to take off this. No, oh, I'm not getting a breakpoint because I'm not actually running from that app. That's why I'm not getting a breakpoint there. Yeah, I'm just in such disbelief about this that I have to see it again. I kind of have to see it. I think Rory's going to be joining us in about 10 minutes. Yeah, so design patterns, according to the documentation I'm seeing, it's supposed to be in millimeters. So no, it shouldn't be. It shouldn't be the case. I feel like you set that up just like yesterday. Julix, what are you talking about? Set what up? All right, let's go over to Leap. Turn it on, show active position. All right. Yeah, it's like at a negative 0.7. It's nowhere near what the number we saw before that looked like it was in millimeters. Yeah. Oh, wait, because it's the palm normal. Hold on. This is why. Hold on. This is my problem. It's not palm normal. It's palm position that I want to get. That's my deal. Yeah, because the normal is always going to be normal, to, set to a length of 1. All right, now do we have better numbers? There we go. Okay. All right, so back here, so let's see. We want, if it is, this is about where we want to go onto the forward plane. So it's about 330, and it's less than 330. That's what we're looking at. Okay? I'm glad we got here and fixed that. That's awesome. Okay, so less than 330 is our magic position right here. About 330, and we're looking to see if position Z is less than that, and if it is less than that, hold on. All right, right. If it's less than that, we're on the forward plane, front canvas. That's correct. Time bearers, all okay, although 0.7 millimeters is wrong. Yeah, no, it was. It was absolutely wrong, and it was wrong because I was using the normal of the palm, which is just showing which way the palm is pointing. It's a great vector, it's useful to use, but not at all for determining the Z position of the palm. So yeah, totally my fault, kind of a lack of understanding on what I was using here. But now I think we've got that understanding back. Okay, so now we know the distance here. The other thing that's kind of useful about those diagnostics we just added is that we kind of have a sense of how loud we want it to be, right? So as it approaches essentially 0, we're going to full volume. Maybe we could even say, yeah, maybe we say full volume is about 80 or whatever the loudest it's going to be. And min volume is going to be back here at, what is that, about 380? I think I want to change my forward plane to 300. Is what I want to do. The mid plane to 300. I was a little confused when you were using the normal for the position, Zulix. Yeah, because, yeah, I was an idiot. Yeah, getting position Z from palm normal Z. Yeah, Zulix, you were pointing me out and getting me in the right direction. I appreciate that. Nope, that was, sometimes I look at, I found this happens and, could be old age, I don't know, but I find myself looking at the code and knowing it's one thing, but it's really not. I have to go back and look in again, and it's like, oh yeah, that's something different. All right. Palm normal, never knew what that meant. Learned something new every day. Yeah, so that's the palm normal is basically that arrow pointing out of the palm to tell you which way the palm is facing. In general, by the way, I really like the API that Leap has given you, right? I like that everything's in millimeters. That's pretty approachable to me. The coordinate system is in millimeters, so that's nice. I like that the thing we just read about the scale, I think scale factor, which shows you is the hand in the process of closing or is in the process of opening. I like that too. Lego International System. What is that putting? Bestest system ever. What are you talking about? You're talking about, you've sparked my curiosity. Now I need to figure out what this is. And in 3D vector math, or even in just 2D vector math, there are normal vectors to lots of things. Yes, well, we use this normal actually to calculate where to put the fireball. So we take that normal and we multiply it, which is only a length of 1, right? But we take that and we multiply it by the width of the hand. And then we pop it out there, and that's where we put the fireball. So when I've got the fireball up, it's using that exact normal. Let me show you that. We'll turn off the show live hand positions. We'll just come up here, bring in a fireball. And it looks like I need to just move this a little bit. Hold on, let's bring it up again. There we go. So, and I got to move slowly too because my sensing for throwing is a little sensitive right now. But there it is. It's using that normal to kind of calculate where to put the fireball. That's what it's doing based on the width of the hand. So I bring it back here a little bit. There you can kind of see what it's doing. So that's the normal. Okay. All right. Yeah, so sometimes I look at code and I think it's one thing and then, it's not, but I just assume it is because I'm not rereading it. It's really cool. It's been interesting watching you do this. Oh, thanks. Yeah, well, we're still I'm kind of calling it comical, right? It's still not yet, I want to try and get it to be believable. Or like, wait, how is he doing this? I want to kind of get to there. And I'm interested in kind of pushing the technology and pushing the code to see if we can get it to approach, believable or maybe to approach unbelievable rather than to kind of be in this place where sometimes it's in front of me, then it jumps behind me or I throw it and it doesn't quite look right, that sort of thing. My vector knowledge is lacking. Well, design patterns, it turns out there's not a lot to it. And I'll also say that when somebody first approached me with vector math, I was like this, like, no, I don't, this feels like super advanced to me. It turns out it's like actually incredibly simple. There are parts of it that are crazy simple and very useful. We're using vector math in here. One of the things we're using vector math to check to see if when we throw, the hand stops moving and goes backwards. And one of the things you can do in vector math is something called a dot product. And don't get scared of, these terms you haven't heard before, like I did. Instead, just realize dot product is a useful way to find out, to get you a number. Oh. Someone's at the door. Hey there, Roy.
Hello.
How you doing?
I am here, and I'm not doing too badly as it happens.
Excellent. I was just talking about dot products. Dot products are a useful way to find out.
Some new dance moves, yeah.
Roy, I need you on the dance floor with a microphone. That's some new dance moves right there. Yep, those are new ones.
There's one.
One. Yep. That's new. And not going to say whether it's good or bad because I don't say bad things about people. But so the dot product. Wait. What about party 3? Yeah, I don't know if I can show that or not. I was going to I'll show it now, and you guys can decide whether this is fitting for a show like today. Here it comes. I don't know. I feel like it's a little over the top for the show.
There are no words.
I was not going to give people control of that one, but I don't know. You gotta figure it out. That's debuted last night on the Dragon Humber show. Useful way to find out party dance moves. That's why you're here. Anyway, dot product tells you if two vectors are going in the same direction. So if I'm throwing my dot product of this speed vector versus this speed vector is going to be, I think, positive. And as soon as I pull back, it's negative. And so it tells us, right? It's just a simple way to do it.
It's kind of like a trajectory.
Yeah, it's actually I know dot products, I know normals, and I know that I can multiply a normal. So a normal is like a 1 unit long arrow pointing in any direction. And I can multiply that by some length, and now I get the longer version of that pointing in the same direction. And speaking of which, watch your toes, kids. Watch your feet. Don't step on the Legos. Mr. Smoopy! Stop the train! Is in the house. Welcome, Mr. Smoopy. Glad to have you with us here. All right. I am in the process of adjusting sound volume as we move forward and backwards. And as I recall, I said I basically got to interpolate, I think is the correct word. Let's see, I want to get my show live hand position here. Here it is right here. So I need to go from my back position where I want the volume to be low, which is about 380, to my forward position where I want the sound to be high, which is probably going to be about 40. So from 380 to 40. So let's maybe add some of those right now. Come on, where are we here? Let me say this dot adjust fireball sound. and we're going to pass in. Do we only have it on hand? Yeah. Hand dot position Z. That's if hand exists at this point. If hand, then we're going to call that. Otherwise, else we're going to say adjust fireball sound, and we want to use thrown object dot position Z. And we need to have an else if thrown object, I think. So if we've got a thrown object, then we can do it. So one of two ways to adjust the volume based on where we are. Okay. Let's create that method.
Do we stop referencing or keeping track of the hand once we have a thrown object?
No, we stopped keeping track of the hand if the hand moves down out of view from the leap motion.
So if you start with a fireball and you throw that fireball, the sound should effectively, by preference, stay with the thrown object.
Yes.
That's your reference point. Now, at the moment, you could still have a hand on screen.
You're right.
So actually, its preference is with the hand at the moment.
Yep, you're absolutely right. Where is that? Where's that code I just had?
If hand.
Got it.
Stop.
There we go.
Yeah,
If thrown object. So we want to swap these around. Thanks so much, Rory.
Yeah.
That was a really smart observation.
I get lucky occasionally.
If thrown object.
Smart comments.
And we're only coming in if we have a sprite proxy here. And I've got this to do here. You know, it assumes our code currently assumes only one fireball. Add support for more. So we kind of need to do that. What's going on here? And following data. Oh yeah, that's coming from what's inside the sprite. Okay. Gotta head out. We'll check the vid later. Okay, design patterns. All right. So adjust the sound. We need to say this dot active leap fireball sound dot volume equals I'm thinking I want a number here. Active fireball volume adjust is what I think I want, or volume scale maybe, volume factor. And I'm going to set this equal to 1 for now, but I'm going to maybe change this individually in my descendants. So Roy, structurally what I've got set up here is I have a sound player declared in the ancestor class, and then the front and the back layers that descend from that class, dragon front game and dragon back game. Those two classes are going to load up a different sound effect. So the back plane is going to be responsible for playing the back fireball sound effect, and the forward plane is going to play the front fireball sound effect. The difference in the sound effects is that the one up front sounds much closer, and the one from behind sounds like it's farther away from the microphone, which is in my theory key to the sense of realism. And what we're going to do is, as we move forward, we're going to drop the volume of the back plane and increase the volume of the forward plane, which I think is going to make it sound like it's actually coming closer to the camera, which is what I want to do. Smoothie says, not so lucky yesterday, spilled water, on my RGB mechanical keyboard, and now it's just a pretty light and less of being a keyboard. You got it. So I've spilled, look at this old guy. I've spilled water on keyboards, I'd say 7 or 8 times in my lifetime. And the key,
is that all?
The key to solving this problem is you flip the keyboard upside down and you immediately start taking it apart. And you pull everything apart. The biggest problem is between the membranes, right? So like in my Microsoft Natural keyboard, it's got 3 plastic layers for the membranes that go underneath the little silicon button, springy kind of things that hold all of these buttons up. And the thing is, due to capillary action, the water can hit the side of that and just start spreading inside. So you got to open it up fast, get those apart, dry those layers up, get all the water out, and then you can put it right back together. Or let it sit overnight if you want to. But that is the absolute key. Yeah, I did do that. It's got MX Cherry Brown switches. I could not save it. Yeah, I've heard about these switches, but I don't actually. I haven't tried them, and so I don't know. I don't know what the mechanics are of those things. So that is too bad.
Yeah.
You might also try like throwing rice in at it next time that happens. That's too bad. Okay, so the volume here is going to be equal to the sound factor. We need to kind of turn this. We've got something going from, do you recall what I said it was? It was something like 30 to 330, I think. Let's do this.
I had a feeling it was going from quite a large number, 330, but to 40, as if it was decreasing rapidly as it came to the front.
Backplane, and we're going to say that's about 340 is what I'll say. And then the front plane.
Zulix suggests it was 380 to 40.
Perfect. That makes me happier. Okay, let's get rid of these squiggly underlines. Okay, so there's my back plane and front plane, and now I need to see where Z is between these two. The higher volume is towards the 40, is what it is. Yeah. So what we need to do is we need to say, I think it goes like this. I'm trying to remember the math on this, but I think it's going to go constant. Percent volume, and that's going to be equal to math. I have a math EX, and inside math EX I've got a clamp. So I'm going to get, first I'm going to clamp this position Z in between these 2 points. So the low bounds is going to be 40. Well, it's going to be back plane. And the upper bounds is going to be the front plane. Okay, so now that's going to give me a number inside there. Then I want to say, I think I'm going to say minus the back plane, since it's the, or front plane, I mean, since it's the lower number. So we're going to subtract that from both of those. And then we're going to divide that by... We're going to divide that by the distance between those two, back plane minus front plane. So we're dividing by now 340, right? So we're going to get a number between 0 and 340, and we're dividing by 340. So that's going to give us a number between 0 and 1 right there. And I think it's, I got to do a 1 minus this. If I just going to put some code in here to figure this out. The examples, put some example numbers in here. So if position Z is equal to the front plane, I want the answer to be a 1. So if it's 40, we're going to basically come in here. So clamp gives me the 40, 40 minus the front plane gives me the 0, and I want it to be a 1. So the answer is 1 minus this. Okay, does that make sense? I don't know if you followed that or not. Okay, so there's
let me ask though, does your clamp routine mind which way around the figures are presented to? Will it work just as well with the large figure presented first, which is what we're doing? So your backplane is a large figure, and it said low bounds for that parameter.
Thanks, my friend. You saved me again. Look at that. Is Rory the best pair programmer there ever has been?
See, I'm asking the question because I really don't understand exactly what clamp does, but I just sort of recognize the parameters were in conflict with the concept. So
yeah, no, I think that's great. Yeah, and you're right. We're only doing this. It's definitely got to be low bounds. Definitely got to be high bounds. Good job. That would have been a bug that would have taken a while to fix. That would have sucked. Oh my God. Do you agree? That would have been so bad.
Yeah, the trouble is it does sort of, it's buried maths at that point, isn't it?
Yeah, hard to find. We need a Rory is awesome. Rory is awesome. Yeah, the closest thing I have is... He's awesome. That's what I got.
Awesome contribution.
Awesome contribution. Okay. Now I want to say this times that.
So just a quick question, a sort of maybe not similar lines, but you said earlier that you'd like to be playing two different sounds and you were going to increase one of the volumes and decrease the other, but we're only dealing with one sound here at the moment, aren't we? Your back game and your front game, we're going to do two subtly different things.
Oh man, you're right. And there's another problem here, which is this percent volume is getting louder if we're in the front plane. We need to find out if we're the back game or the front game is what we need to do. This is like percent volume is like there. Wait, hold on. Percent volume for the back plane looks like this. Percent volume back plane is like that. Percent volume front plane is going to be 1 minus that. Then I think what we need is something that's going to be a just our overall percent volume. That's going to be if this instance of Dragon front game, then we're going to say percent volume is equal to percent volume front plane. Like that. Else we're going to say it's equal to the back plane. Then we're going to use percent volume. Oh yeah, it looks like we're using that right there. Okay, cool.
Cool.
All right. Is that better?
I think so.
Yeah. Okay. Better. All right. I think that's better. This is just telling me I don't need the number there because it can infer it. So the fireball volume factor is there. I think I also want to not really update this 1,000 times a second.
Fair enough.
What I want to do, or 60 times a second, what I really want to do is I want to see, is it changing significantly? So I think the way I want to do this is I want to say, hey, percent volume is equal to percent volume times, and then I want to basically, do I have a math.round that can, is there a math round that can take number of digits? I don't think there is. Yeah. So do I have it in my math EX? Do I have a round in here? I feel like I should have it, but it looks like I don't. Hold on, let's turn on IntelliRush here so we can see more. Yeah, I have bind. What's bind? Oh, this is interesting. That's not even mine.
I think that's probably coming from object or something.
Yeah.
Well, yeah.
Something else. I've got truncate.
Truncate.
What's going on with truncate? Nope. Nope. All right. So I'm going to fixed. There it is.
That'll work.
Oh, parse float to fixed. Okay, cool. So we're going to do to fixed. Number of digits turned to a string, then count for length. Yeah, kind
I'd
of.
say pudding. That's what I was thinking of as well.
Yeah.
I was thinking it's all I can come up with right now, and I know there's better ways to do it, but...
So now what I'm going to do is percent volume. I'm going to say number of decimal places. I'm going to say 2 or maybe 1. Let's just do 1. And now what I want to do is say, hey, look, if the existing volume is different, then we're going to change it. I just don't want to be, a jerk and do this all the time because, you don't want to be mean to your HTML audio files. Elements. And all right, so there's my justifiable sound. I think it might work. All right, so that's in the Dragon game. Let's refresh only the front game. I want to refresh only the front game so we can only hear one of the two sounds because, and then I think I also want to then again do it with only the back as well so I can isolate them so we can hear and verify they're both working. Okay, so let's see what we got here. Fireball.
Ooh.
Nice.
That's pretty good.
That's not bad. Hold on, we got to get the leap, got to move it a little bit so it's right in the right spot. My throwing is sensitive. All right, I think it's going to work. All right, so there's that. Now let's look at the back game. I'm not sure if we can disable the front overlay and look only at the back one without hearing the sounds, because I've seen when I've disabled in the past, it's still running code for it. But we'll see what happens here. So let's get back over. All right, where's my hand position? Why aren't we showing live stuff? Oh, because we're showing only on the front overlay and I disabled it. Okay, so fireball. So I've got to kind of move back. I've got to do this apparently for fireball. Hold on. That's not working at all. But I'm wondering
Something's very strange with that. I'm not sure exactly what though.
I think it's the front. The front is still playing. Yeah, and when I did that, it was like, yeah, the front was still playing. Let's go take a look at the...
Well, you could hack the code for now and just set the percent volume equal to 0 on front game.
Yes, I could. Give me a second though. I want to verify that the fireball far and fireball close. I am doing both of these two different ones here. This is the dragon back game constructor. That's the dragon front game constructor. Okay. All right, so let's do that. Let's do the hack like you described.
So 1187, you can just set it to 0. Is that right? I was just saying you could set the percent volume that you already had on the line.
Oh, I see.
Because then it'll ripple down into the rest of it and...
Fine. That can work. I think I also need to check to see if this thing exists or not. Just in case. Okay. Now let's try it that way.
Fair enough.
All right. Let's refresh. There's the front. Refresh the back. Okay, here comes a fireball. Nice. It actually is working. So it's getting louder as I move back, but it's the back one, right? Do you hear what's going on, Rory? It's the back sound. As I move forward, it gets quieter.
Yes. And I guess that's correct, isn't it?
That's what I want it to do, because I want that one. It's just not getting very loud, but it's kind of there. I think let's combine them both together now.
That should have quite a nice effect with them together, yeah.
Theoretically, that's the theory, right? That's what I'm running with here. Just for symmetry, I'll put some braces here and here. Okay, let's refresh the front overlay. Don't think we need to refresh the back overlay. All right, here we go.
No, that's good.
Yeah, it's not bad. Let me try a throw. See if we can hear it. That was kind of interesting. Here we go. Let's do it again. Throw. Try again. Throw. Something's wrong here with the... It's kind of jumping back. Why is that? Why is it jumping back? Back plane, front plane. If thrown, if there's a hand, if it's position Z, thrown object position Z, I need to look at position Z here, because this was, we found a bug for the thrown object. And I want to make sure we're grabbing this from the right space. Current position.Z, that looks promising. Okay, looks promising. Mr. Nolly says that's awesome. That was an issue that you had yesterday as well. Yeah. Yeah, it's definitely going to the wrong plane. I don't think I had this problem yesterday. If I throw it off to the side, you can't tell it's on the wrong plane, but there, it totally is on the wrong plane.
I don't remember if you solved it yesterday, but I do remember commenting that there was a presumption about where the midpoint, the transition between the planes should be.
Yeah.
It was a fixed value at the time.
We fixed that with your help.
We debated that it was where the hand actually was at the moment of release.
Yes, we've got that now. So if on the front canvas, if the hand exists, we have the position Z, the hand is less than, now this is wrong. This should be here. What was said, we had, the code was working yesterday because we had incorrect data coming into position Z. I think this is the solution right there. Let me try that. We're gonna I think I see an issue. Cool. It's my favorite part of the show. That's the front overlay. I'm gonna refresh the front and back overlay. In one part of the code, you choose 330 for the midpoint. I'm choosing 300. I changed it to 300 right here, midplane Z, right there. And there you have it set to 300. This is I just changed this manually. This used to be 300. That's the midpoint right there. That midpoint is only used if there's no hand data, but because I'm holding my hand up, we need to check to see what is greater here. So on the front canvas is, wait. Hand position Z is greater than, yeah, because the positions get bigger as we go back. So this I think is totally the fix. Let's see, drag in back overlay. Let's refresh that. And let's do that update. Now I think we're gonna have some good results here. Try again. What? There we go. All right, throw it. There it is. All right. All right, cool. We still have this. This is this weird thing. What's happening, I believe, is we're getting past the front plane of where we are, where we have tracking data to map three-dimensional space into two-dimensional space. Because that's what's going to happen. As I move my hand up too, what are we doing here? You see what happens with my hand as I move it up too?
We get negative figures and stuff like that.
Yeah, it starts getting out of bounds. And this is, we're seeing essentially like an error in our three-dimensional to two-dimensional mapping that's happening once we get outside that forward tracking plane, which is like about right here. So I don't have a great idea for a fix for this yet, but I'm not sure what it is. I don't know what the answer is yet on that, but it's not great. I've thought about a couple ideas. One of the ideas I thought of was, when I see variations, like here the fingers are really high, like here I got a little bit of a problem. Let's see if I can get this, move this, get this in a spot where that kind of is not too bad. It's not too bad. Yeah, let's actually come back over here. So that's good. So we kind of start to lose things a little bit. Yeah, I'm convinced that there's a combination of calibration plus the idea is to put like where it starts to fade is to kind of put a virtual anchor point that sucks it back in, like a gravitational point, that as we move closer to that point, it moves closer to the center of my hand. And I figure with a few of those, I can get this so it's looking pretty good. Again, we're doing this kind of really weird kind of thing, which is we are taking three-dimensional data and we're mapping it to a two-dimensional space that is skewed by the angle of the lens, the wide angleness of that lens coming in there, right? So
yeah,
let's do this. Let's see if I can get both hands right there. So there. So it's not bad, but there's a little bit. Whenever we kind of lose things a little bit, that's not great. But it's not in this space. It's not bad. Right? You can kind of getting a sense of what's going on. Here you can see, look at the fingers going really far away. Right?
Yeah.
And I kind of want to bring those. It would be nice to be able to just have this nailed, this 3D to 2D math conversion nailed. I thought the theory was pretty good, and it's kind of good, right? I'm certainly getting the palm there. And for the
I mean, it's not wildly inaccurate, is it? They're in the right general vicinity.
Yeah, and when I do like an effect like this or something like that, right? It's believable, right? I think it's kind of what you combine that with a sound effect, and it's going to be believable, right? Fireball back here, fireball. Yeah, it's not bad. I need a sound effect for when that fireball is done, when it exits the plane.
Yeah. It's like dipping a match in water or something.
Yeah, something along those lines.
Do you want more explosive, perhaps? I don't know.
Destroy all fireballs. There, I think what I want to do is say, hey, if this dot count, dot length is greater than 0, then I want to play this dot leap, what is it, leap, effect sound manager dot play. It takes an audio element. I don't want that. I want to say play, safe play MP3. I'll take that one. And I want to pass in fireball extinguish. Okay. And I've also got a fireball ignite as well. So there's going to be my extinguish. And I think I want to only do this on one of my planes. And this is, this instance of Dragon front game. So only do it on the front game. Okay, like that. And then when we go create a new one of these right here, maybe when we call add fireball sound, I might come in here as well and I might say, if we're on the front plane, then we're going to call fireball, I think it's ignite. I think I've got a safe play in like that. What do I have?
In after something like that. I'm sure you did.
It was something in play MP3 in, and I give it milliseconds. What does it return? I want to know if it returns the. Oh, it can't return it because I can't do that. Okay, so we're going to just say. Safe play MP3 return audio. We'll do that. Roy's falling asleep.
What makes you say that?
All right, that's what I think we're going to do. So let's try that. Let's do a refresh on the overlays with that. There's the back overlay, getting a refresh. Here comes the front overlay, getting a refresh. I have special powers, lol.
Okay.
Okay, and refresh both of those. And what do we got? Okay, fireball. So I want to do the sound. Okay, that's not bad. The ending was not bad. The front was not great though. Because, part of the problem is, look, I'm trying to get that audio back. I could add some space in the beginning, which I think I'm going to do. I was originally going to loop these, Rory, but they're both over a minute long. Ooh, and I'm like, you know what? I don't think I need to. I don't think I need to loop them. I'm not going to be playing with the fireball more than a minute. That's my idea, right? Maybe we'll do that. And if I do decide I want to play more than a minute, then I'll make these 3 minutes long. Right, so I think what I'm going to do instead is, what do I have here? I think I can just copy, like I can say, okay, let's see the other one. Let's look at the ignite. Or I could actually just put the ignite here. But I think I'm not going to because I want to have, let's just see how long it is. It looks to be about 1.2 seconds long. So this is the fireball far. Where's my insert silence? Do I have to? I think I might have to copy the amount that I want to insert, copy it, paste it, and then silence. There. All right, so there's my fireball far. And actually, to be fair, it's not really 1.2 seconds in. It's about right here in this space, 0.65. So let's go find that. It's about right there. So we just delete from here to here. Save that. I'm going to copy that and go to Fireball. I don't know. Yeah, Fireball close I have right here. And I'll insert that as well. Can I paste that in? And I'll save that. The only problem with that change is we won't be able to test it really today without restarting everything because it's caching
the specific audio.
It's caching the audio. If I renamed the audio, I could make it work. Maybe I'll do that so we can hear it today. So we're going to call this close.
The references to the audio files that you use in order to say play this audio file, are they simple HTTP references? So they're not looking on disk per se, that they are theoretically, because when we want to do stuff like that, because you could apply like a version number and just have a random, if you, for debugging purposes, you could say I don't care, read it off the disk every time, and just stick a random number in a kind of a question mark variable. So my mp3.mp3 question mark ABC equals 123 or 1234 or 12345, effectively referencing the same physical file every time, but the browser mechanic for retrieving it doesn't know that. It thinks you're asking for something fresh because it doesn't match the name it has in the cache. Works with web stuff.
Tell me what,
I don't know if this.
Tell me what you're doing to get it to read.
So we do this with JavaScript. So whilst we're debugging, we just throw a random number in effectively. So you'd be myfile.js, and if you ask for that a second time, well, the browser's cached it already. So just like this situation, it doesn't bother to go and load it, even though in sometimes cases it's changed.
Yeah.
So rather than reference it directly, we reference it and then suffix a question mark myparam equals, and then we just throw a random number on. Okay.
Oh, Coding Gorilla's got it.
Unique every time.
That's nice. It, yeah. I didn't know you could do that.
Now, okay. I don't know if this would work in this context with MP3 files, or if it is even a sort of a cache. If it is a HTTP style cache. Yeah. See, I waffle on for ages, and Coding Gorilla does it in one line.
Wait, why are we back there? It doesn't like the... Here we go. All right. Hold on. The fireball's got to fade in. It's getting better. It's still, there's some comical problems, but looks like we did not end the back sound. Why aren't we ending the back sound? Destroy. We should be pausing it. I'm not sure why that's the case. Let's go switch back over. All right, I want to do a fade in. It's about 1.2 seconds when we add the scaled sprite right here. I'm going to come in and say fireball dot fade in time equals, let's do 0.65. Or wait, that's 650 milliseconds. As I recall, we're dealing with milliseconds here. Yeah. So 650 milliseconds will fade in. Dragging back in was not saved. That could be my problem. I hadn't saved this. It may not have been opening up that new file. Would that make a difference? I'm not sure. Okay, let's refresh. Yeah, we're getting closer with the sound. I think as I bring it in close, I'm like, oh, yeah. Here, let's turn off show live hand position. So we've just got this. Nothing. Where are you? There we go. Much better.
That's good.
Yeah. It's not bad. Throw it up. That's weird. But
That was strange.
I think again, it's happening because as we're getting close, as we exceed past the plane, something's going crazy with regards to our math. I think there's just a math problem there. I want to throw it straight
that
up.
appearance is really nice now.
There's the throwing up, and then it comes back down. That did not look right. The it should have fallen down in front of me. There's that magic number 300. If it's thrown, so here, all right, position Z, front canvas, less than the midplane. No, that should be right. It should have found it on the front canvas. It should have worked. Seems like it should have worked. Thrown objects, position Z. Yeah, that looks like it should have worked. I'm not sure why that didn't work.
Hang on, is this another case where... No, hang on, maybe it isn't.
That time it worked. I'm not sure. I'm gonna get it behind my head, and I'm gonna kind of. Where are you?
That was strange.
Yeah.
So that was good.
Yeah, not bad. I like that I can throw it across the front of me. Like that. That's cool. Yeah, you see it was behind me a little bit.
Yeah, it was just for a fraction of a second. It started behind you, then it transitioned.
Yeah, I'm almost thinking that this is like, you know, we could also maybe make the argument. Oops, hold on. Let's try changing it to 330 again. Properties, refresh.
But doesn't
cache.
that only have an effect if for some reason it loses track of your hand? And in that action, it shouldn't have lost track of your hand. It was pretty consistently in view.
Yes, I think you're right. That midplane Z would not have an effect on that.
Which is a shame, because other than that, it's a good theory, and I don't have a replacement one for this circumstance.
Yeah, I'm also thinking, well, what if we lost data for a second? You know, there's a chance it could have worked. I don't know. Let's play with it for a second or two. See what we get here. Where are you? There you are. Yeah, it's too sensitive on the throw. Yeah, there my hand kind of punched through it for a second. And it totally, yeah, there it did it again.
Yeah, because of course it's going to do the speed forward based on the speed of your hand. But if your hand is actually accelerating and it winds up moving quicker than the fireball, you'll punch through it.
Oh, right. It is, in other words, if this is going slowly and my hand moves faster than it.
Yeah.
Yeah, because we don't have anything that if we say, okay, that's a throw, and then I start pushing through it again, we don't have any code that says, let's keep it going. So, I almost think that's kind of okay. I think it's okay. I want to get the throw so that it's not so sensitive. I want to get that. I also want to do, I don't know if I can do this or not. My hand's out of frame. Okay, so this is happening because it says my hand's kind of facing kind of up and towards the back a little bit, right?
Yeah.
So it's putting it behind me, right? But it really should. I need to change this too, so that my hand is kind of in the upright position, right? That it maybe puts it in front of me, like that. Well, it depends on where the fingers are, I guess, right? Too. But see, here is so as long as my hand isn't. If my hand's off to the side, and I say just kind of like, here's a fireball for you, my friends, like that. That's not bad. If I lean it like this, though, in order to show it behind the fingers, it draws it on the back plane, and the illusion is destroyed if I go here, right? And so if I'm ever going to cross my face, I need to kind of go like this. I need to kind of get it onto the front plane without my thumb being so frigging in the way. So I need to kind of spin it like this. See what I'm talking about? It gets a little comical.
Yeah.
It gets a little comical. All right, that one didn't look too bad, actually. That one looked great. If I turn my hand sideways like this, it's not bad. So here's the turn, and then move it across the front like this. And then once I'm over here, I can then come bring it back over here like that.
Yep.
Okay, not bad. The sound definitely improves it.
Oh, yes, very much so.
Let's make it so throwing is a little harder to do. Let's see if we can tighten up the constraints on throwing. And then we'll work on catching, I think. Maybe we can get all this done before Rory has to go.
Juggling.
No juggling, I think. Juggling, I need to support 3 different fireballs, and I'm not sure about that. But there is something about it now, and I'll tell you this. This is, the better we get this, there's this element of kind of surreal feeling that I have, which is, why can't I feel the heat of the fireball? Why can't I see the light of the fireball? Why can't I feel the heaviness of the fireball? Right?
Okay.
The closer,
Items 1 and 2, you might be able to do something, but wait.
Yeah, I'm not sure about it. But
that's a challenge.
Yeah, no, I know. I'm going to do the light. I really feel like we're working hard enough on this. I'm going to make it so that I move the fireball close to my face. The color of the fireball, that light shines on my face. And I'm going to try to make it so it's brighter as I get closer to myself. Right?
Sure.
So I'm definitely wanting to get there. But it's this weird kind of world where my brain is like, wait, what's going on? Right? I just was holding a fireball in my hand, but there wasn't complete evidence that it was really there. And I've just been noticing that. I've been noticing that feeling as we're getting closer and closer to making this look and feel real, there's something both there and missing with regards to my recollection and my memories of holding the fireball.
It's sort of the pushback of the virtual object on the real world.
Yeah.
That's what you kind of want to have.
Yeah.
And at least in the case of the light, that will be visible over the stream. Heat and weight, not so much.
No, I know, but I'm just talking about what internally I feel like. In other words, we're getting it. It's as it gets more and more, we're starting to essentially, substitute for my senses, right? As I'm working with it, more and more, I'm like noticing the senses that are missing, that are not quite feeling right.
Sure. Yeah.
Okay. We're in the D&D app. Somewhere in here, I've got something called throwing. It may be in the class I'm in. Throwing. When that thing is set to true, there's when it's set to true.
Mm-hmm.
This is where it's decided, I think. Nope. Get throw vector. This is where we're deciding.
There you go. You've got some constants up the top suggesting min and max various things.
Yeah. We're not really calculating this correctly. This is I'm worried about this right here, 86. So there's 2 things that we're doing here. We're checking to see if our speed is less than whatever our fastest speed is minus our min delta speed for release, which is in this case 100. Looks like I'm even using this. This is poorly named. It was you doing something else, and I'm using it in kind of a not a great way.
When it talks about delta speed, since how far in the past? So we're
whatever
evaluating
we're-
this in the moment, but we have to be doing so relative
Yeah,
to...
whatever
Oh, I
we're
see.
looking back in terms of time. So we say, here's our earliest valid time.
Okay.
So I think I want to come in here. I think we want to tweak these is what I think we want to do. I think my min delta speed for release, well, I guess that could be, the question is how far from the fastest speed can you be in order for it to call it that it is a throw. And I really think instead of having it be an absolute number we go back in, I think it should be a percentage of my fastest throw speed. So if my fastest throw speed, yeah, the problem is we're just not using the actual laws of physics to throw it.
No.
That's what we're failing to do. The problem is I'm not an expert in this. There's no way I can crank this out in a short period of time in terms of figuring that out, right? We're essentially taking an object and bumping it, right? Pushing it, and then it reaches a velocity, and as our velocity slows, it separates. But if we come back in, right, because even if we look at this as a small little segment of time, it might separate the smallest amount. And then we're pushing. Looks like we got a raid, kids.
We got a raid. We like raids. Welcome, C# Fritz, and everybody who's come with you.
Hey kids, welcome. Glad you're with us. We are in the process of coding.
They're going to believe this.
Doing some math.
This sounds pretty unbelievable.
All right, I'll show you what we're doing.
We're throwing fireballs.
Geniscu 7, where are you?
Here comes Geniscu 7 coming in.
Oh, yeah, alright.
Show you what we got here, kids.
Here, too, I am.
Hey, everybody. You're looking at some data we're sending out here coming from the Leap Motion controller, which is right here. Coming from Leap Motion, I think is what the device is called.
Corner there, just on Mark's keyboard.
Yeah, right there. That's it. And it's telling me, for example, whether my hand is facing forward or backwards or left or should be right over there. It's not perfect, because it's only got one point from which it's viewing the world. And so if I even take my fingers and kind of make it so they can't be seen, right? That sort of thing. Why are we doing this? Well, we're doing this because I want to be able to throw fireballs. Whoops, let's do this. Let's clear this.
Perfectly natural goal. Yes.
I just want to throw fireballs. It's a simple kind of thing. Here let's do it again. There you go. So there's my fireball. And here, the C# Fritz is coming in just in time to see the fireball. C# Fritz, look out for the head, not the fireball. No. Stop. Whoa. That's C# Fritz, kids. So cool. So I got a fireball
cool, yeah.
in my hand, right? And now what I want to do is, the throwing is too sensitive. Sorry, kids. But we worked on this today. It's kind of cool. If I move it back, listen to the sound difference. And then as I move it closer to the camera, here, let's do this. Right in there. It's a little bit. It's a little bit not quite great. So back.
Well, we're getting there.
We're getting there. Back. Come on. Back. And then forward. Back. And forward. Back. And forward. Let's tell you what's going on. There we go. So
As Zoom
back,
says, it is a work in progress.
yeah. But listen to the sound as it comes close.
Good.
Yeah. So that's kind of cool. We're getting kind of there. So there we go. That's nice. I can also kind of make it so it kind of scales a little bit. All right, we're working on the throwing right there. It's a work in progress. We're working on it.
So our declaration was that our throw is just a little bit sensitive at the moment, but since we're not using as wonderfully accurate maths as maybe we could, but that might be a bit more awkward to do so. Well, let's have a look at what are we doing here.
We've got the leap motion right here. The leap motion is providing skeletal data in a three-dimensional space. Essentially, and the units of measurement are millimeters. And so it gives us three-dimensional signal. We are basically mapping from the 3D world to the 2D layers. Did you guys hear something? What was that? Huh? What? That guy always sneaks up on me. Wicked Blue Ninja's in the house. Hey, kids. So we're mapping from the 3D world to the 2D world based on this camera's perspective. Lassamat's here.
Everyone's showing up.
C-Sharp Prince is like, what's going on, man? All the fanfares. Envision and mapping. Yeah. So basically, then we come in. Where's this? We basically come in and we just kind of set some coordinates in space. I say, here's this point back here. Here's a point up here in the front, and we kind of take that data, and then we map on. And there's a whole bunch of math we worked through earlier when we were working this whole thing out to figure out how to project onto the 2D plane and have it match the aspect ratio. Well, not the aspect ratio, the wideness, the angle wideness of the lens, right?
Yeah.
That's what we tried to do. And it was not bad. Our results are not bad, as you can see. We're still having some, the data that's coming in, it's detecting it using two cameras. So if my fingers are blocked by my hand, then, we have some problems there. With regards to seeing, what its positions are. So it's not perfect, but it's actually pretty cool and impressive based on the amount of time we put into it. We've been working on it. I think this is our fifth show that we've been working on it. So this was about after 10 hours of development. This is where we are right now. And I'm still interested in kind of getting to a sense of making this thing look and feel real. And I want to get to the point of I want to have two lights here and here that are kind of pointing in at me that I can, the Philips remotely controlled LED lights, so I can change the light color hitting my face based on whatever color fireball I have holding and I'm bringing close to my face. And when I move close to my face, we see the brightness on my face increase, and as I move away, it decreases, and depending on where it is, the appropriate light is turned on to make it look like it's actually light wrapping around my face. So that's what I want to do. Okay. C-Sharp Fritz says that is going to be an awesome effect. Well, we'll see. I really wanted, it's got to be, it's for a live show. It's for a show out there. If you guys like Dungeons and Dragons, it's another stream we're doing out there. Go take a look at it there. Give us a follow. It's for that show. It's essentially an R&D phase now, but because it's a live show, it's got to be, flawless all the time. But I will show you some other effects that are actually they're really close to, they're just missing some sound effects in here. But if I come in here hold on, be careful about this cord right here, young child who's approached my desk. So if I come over here and I just do something like this, right? Or here like this, or come back over here, right over here, and do this kind of a thing, right? I can kind of do an effect that looks like I've got some sort of magical kind of power coming out of my hand, and it's scaled depending on where I am. So if I move in really close, it's really big, and if I'm farther back away, it's smaller. It's a little bit off, and I think it's just because of the position of this guy right here, is what I think. But it's this kind of thing could be really useful, I think, during the game, where you're just in character and you're like, I'm going to cast a spell, that sort of thing.
Yeah.
Wait, you don't have magical powers? Asked Coding Gorilla.
Well, magical coding powers, sure.
Don't ask questions like that, Coding Gorilla. I'm going to throw a fireball at you. Okay, so there it is right there. His magical powers, he just isn't allowed to tell us.
There you go.
So we were just, as you guys all came in, we were just kind of commenting on the fact that when we throw an object, here I'll maybe use this as my example, fireball. When we throw the object, essentially what's happening, we've got the vector, the velocity vector. We have to get to a certain point, and then we can kind of say, okay, that's now at throwing velocity threshold. Then it's got to drop below it, okay? But what we're doing is we're kind of really cheating. We're cheating to calculate this throwing velocity vector. And as a result, we're getting kind of these false triggers, that sort of thing. And what I want to do, well, I don't know if I want to do this or not, but the idea is that, look, as I'm throwing this, right, if it comes off a little bit, but my hand speeds up, that's okay. I caught it. It's essentially a catch, and I'm pushing it even more, right? Yeah. So I want to be able to kind of like, do that until there's a significant change between my velocity and its accelerated velocity. I do have this min velocity for throw. I have a min delta speed for release. So right now that's an absolute change, and I'm really not feeling that that's right. I think what I want to do is I want to say, I really want to do something. I feel something more like this. Here, let's set a breakpoint here. Get my hand.
You're saying it was like it should be a percentage of that fastest achieved speed.
That's what I'm feeling.
It's a fall off of however fast you've got to so far. So if you do a small throw, then yeah, it's a small fall off. But if you're doing a big throw, you should see something more definite before we decide to throw.
Right, exactly. So let's see here. Do I get a throw? Why am I not getting a call here? Let's show live hand position here. Do I have to have a fireball in my hand to throw it? Maybe I have to have a fireball. There we go. I did have to have a fireball. Okay. So I guess my new idea is min delta. I want to change this to like percent. Percent for release. By the way, kids, we're working in C# and TypeScript right now. So I'm going to say it's got to be, maybe this is going to be max instead. I'm thinking it's going to be like 82% or something like that. Max percent, wait, percent.
It's percent of max?
Throwing speed for release. It's kind of a max number. It's the most it can be for it to consider it a release. So then what's going to happen is if the speed is less than that times that, and then or this just checks to see if the dot products are in the opposite direction. Okay? Yep. They can be in the opposite direction, but we have to have I'm going to lose signal R here if I stay here much longer. Let's throw that. Let's run that. Get another breakpoint. Okay. I want to drop this amount of time too. I want to look only in the half a second back in time. And now let's run that. And let's just see if we get throws here. Okay. All right. So I need to get a fireball in my hand to throw it. That was a throw. That was a throw.
Yeah.
Let's hold it this way. That was a throw.
That was good. I gotta say, these new figures are working pretty well.
Yeah, I'm not getting the. I'm not getting that. Let's come over here. Yeah, I'm not getting the false positives we were getting before. All right, I think I can live with that. I think I can live with that. Whoops, let's get that done. Yeah, it's not bad. This is way off in the back.
So can you do the manipulation you were trying to earlier, where you get the fireball and you're now moving it to the front, but not meaning to throw it?
Oh, right.
So that it stays
good question.
in your hand.
Good question. All right, so let's look at that. That looked like no on that time. That time it did look like it threw it. So I'm just going to turn it around. Yeah, it is. It's throwing too much.
Okay.
So let's kind of figure that out and set a breakpoint. So we can come in here. Let's get a fireball. Let's drop this number down. And I I almost say let's drop that number down too, as well. All right, let's run it. Try again. Okay, here we go. All right, turn it around. Nope, we got all kinds of throws in there.
I
Turn it
wonder if
around.
there's the other figure that needs to be changed. Because you were talking of a fall off of speed, but if we say you have to get to a higher minimum speed in the first place, that'll give you some leeway when it comes to moving slower.
Yeah, it sounds like we're getting suggestions of the same thing. Making this higher is what you're saying, right?
Yeah. I
Okay.
don't know what the percentage figure was before.
It was 60% of that. Well, it was 80% of that before. So now the speed's got to drop below that times 60. So it's got to go to almost half of its speed. So let's see what we get there. Can I turn? Still got a throw there. Let's see if it interferes with... Come on. Give me a fireball. Do I need to switch? All right. Good throw. Part of what's going on, look at the diagnostic data. Look at the left. See how it drops down all of a sudden? If I'm
Yeah.
see it, it's considering that a velocity change. That's part of my problem. Is that the data I'm getting, this is not bad here. There it is behind me. Let me turn off the show live position and bring it back up. Turn it behind me. Give it in front. Turn it back. Bring it in front. Got a little bit of a throw there. That was an unexpected throw. There's a real throw right there. Let's crank the speed up even more. Because I think it's actually, helping. That change is helping. Let's make it 700. So do a small throw. The small throw still worked. It still threw it.
Interesting.
That one stuck to my hand though. Okay, that was kind of cool because it kind of stuck. Yeah, that's stuck. So a small move like this and a bigger move throws it. That's actually
Mark can't just throw fireballs now. He can threaten doing it ahead of time.
That's so funny. You want some? You want some of this? Take it. There you go. That's kind of cool. And I can throw it across me in front of me too, like that. Anyway, gorillas have no magic. Mine is wiggling. That's your superpower. Good job. And throw it up. Yeah, that looked like it was a forward. I want it to go up. There we go. I want to be able to throw it up and I want to catch it. I want to be able to catch it. That's the next thing I want to do. Up. And, it went way behind me though.
Someone's going to have to dive behind you to catch that
I can't really get that if it's that far. I got to really...
I just have this visual now of Karen literally diving across the screen to catch that one.
I want to catch it. All right, so now let's work on the catching code. I think the throws, it's not bad. It's
That's
like,
not bad.
we're like basically at Boy Scout level here. We're like, we're not the pros right now, kids, but it's not bad. It's working. Okay, so catching. That's going to be up here in C# where we're going to figure that out. Get throw vector. Check for throw. And I think we need a similar check for catch is what I think we need. Yeah, it's not ILM. Not ILM. All right, so check for throw.
It's MIL.
Yeah, what's that?
Mill.
Lure. Okay. Check for catch. Check for catch. So this should be hand 2D. And I guess we'll just declare that. And I'm not sure what we're going to do in here just yet. I'm going to run it and let's think about it. We've got some objects. Okay, we've got some objects that are flying. Where are they? They're inside world.
Thrown objects in the world, yeah.
Yeah, world dot instances. I think we could do something like this. That's our virtual 3D object that's being thrown. And I think we want to say, we want to get the distance between the two. So that's going to be a, I think I created a new template for vector. Yeah, so vector, we're going to say distance. That's going to be equal to virtual, well, let's start with the hand. I taught my son this, by the way. I was like, if you want to figure out the delta to get to something, your equation is always you start with the target you want to get to and subtract where you are. And so, you know, I said, I've been doing this, I've been coding for like, 40 years almost. And it didn't occur to me till like this year that was the way minus works. That you have to start always, right? In other words, because I could start with the other way and do the minus, I just get a negative number. But if I always want to know the answer to the question, what do I have to do to get to some place? I start with some place first and subtract me. And then that tells me how to get there. Yeah. And it's like, in hearing myself say this, it's like, of course, it's intuitive almost, Mark, but it's never anything that I had in my head. And whenever I did this, I'd always subtract one from the other because I know that's the delta. But I never really thought about from whose perspective until this last year. Anyway, all right.
Fair enough.
Hand.palm position. Yeah. Roy's like, I thought about that when I was 3, but okay,
no.
fair enough.
I'm absolutely with you on this. I know it's, one thing take the other, and yeah, then I'm going to reverse it when I find out I've done it the wrong way around.
All right, so I'm going to use some vector math here. Why aren't these working? Oh, that's a scale point. That's not good. Check for hand. It's the hand to D. That's not what.
We could have a scaled point which has a distance to other scaled point, couldn't we?
No, I don't want to do that. I want to actually do it in 3D space. So we're going to need to do this. Let me run. I'm going to lose my signal R here in a second because of my delays here. Let's just run it like that. I don't know if we're going to, we've probably already lost it. What I need to do, you know what, I'm going to kill the app. I'm just going to kill the app because we need to, and we'll restart it. We need a palm position 3D is what we need.
Mm-hmm.
And that's going to be a vector and palm position 3D like that. And I am not going to send it down. I'm going to do a JSON ignore on that one. Okay.
Okay.
Now, whenever we set palm position, we're going to do this like that. And so that will get us that 3D position that we need. Okay. Now that we have that 3D position, we're going to use it here. And that now should work. So now we've got our distance as a vector. Okay. And then I want to say, hey, if distance dot magnitude, this is the other cool thing. If you're not familiar with vectors, they have a magnitude, which is the length of the vector. So if I say that magnitude is less than whatever my min threshold is, I don't know, let's create like a min distance for catch. And this is going to be in millimeters. So, I don't know, 60? Is that crazy? 100? Maybe 100. Let's make it 100.
100 is decent. Yeah.
I'll be catching things all over the place with 100. Maybe let's make it back to 60.
Depends how far you throw them.
Yeah. Well, I'm going to say, if it's really far forward or back.
I was going to say, forward or backwards got to affect this as well.
Yeah.
I'm pretty sure that we're not throwing things straight up and down each time.
Yeah, you're right. We could clamp down the Z. Because I'm really more interested in the X and Y. Really. Sure. I could clamp down the Z. Let's put that as a to-do. Clamp down the Z. Z, so we can easily catch fireballs thrown way behind us or way in front of us. Okay, so if the magnitude is less than min distance for catch, then we've caught it. Now what do?
We've got to connect it to our hands, such as it would have been when we'd conjured it in the first place. So it is no longer a thrown object.
Yeah, I think what I want to do is I want to create a new list of these objects here called caught instances. Right there.
How does a caught instance differ from one that has not yet been thrown?
Caught instances, I'm just going to collect them as I get in here. I'm going to come in here and I'm collecting because I want to remove them later. But I don't want to remove them right now. So I'm just going to say add the virtual 3D object. Then down here, I want to do something like world.remove instances. And I want to pass in my caught instances. Something like that. And then we're just going to say instances. Oops. Instances.remove. We got to remove all in here. What's that? Remove range. No, I think I just want to remove. Like that. Sorry, virtual 3D object. Like that. Okay, so there's remove. Like that. Okay, so that's going to clean them up, get them out of there. Now at this point, I want to come in and say hand dot. I forget how we did this before. Throwing equals false. Okay. Thrown object index is equal to -1. And there's something else when we attach the fireball to it, as I recall.
I'm assuming it's the object itself, isn't it? So the object is told that it is connected to a hand.
Oh, it's the object. It's actually it's maintained down below.
Okay.
Which means we really kind of need just caught is equal to true. We need that, and I think we need a caught object index. Is kind of what we need. I think that's what we need. What about juggling bananas?
You're hoping to have a fireball in your hand, which is just sat there, and we throw it, and it's added to the list of thrown objects. So we have a thrown object index in that. And then shortly afterwards, when it goes up, comes down, you position your hand correctly, we're going to catch it. Which is fine. I'm just curious again though, if we had it in our hands before and we didn't have a caught in object index, why do we need one now after the fact when we're surely returning to the original state?
It's a great question, because we need to know when we get down below that the object that is now separately flying away from us needs to get reattached. When I say down below, I mean in TypeScript. So this is going to give it a signal that it needs to be reattached. This is going to tell us which one to go find to reattach.
Sure. Okay,
that's my theory.
Makes sense.
That's my theory. I just added these here and here, throwing and just caught and caught object index. I need to do the same thing down in TypeScript. See if we can find that throwing, get close to that. And now just caught, I think. Whoops. That's going to be, actually, let's come down here. And this is going to become just caught. Like that. So now if we look at throwing, check for throws, we do this. See this hand following data tracking object index? We set that equal to the object index. That's inside the sprite. So the sprite knows what object index it is in virtual space. Now what we're going to do is we're going to say, we're going to find that check for throws. We need a check for catches here, I think. Uh-oh. Hey, slow down, man. Slow down. Look out, Fred. What did I miss? Everything, Screech Rat. You missed everything. Tell him, Roy, while I figure out this code.
Well, depending on where you last visited, we now have fireballs. We have fireballs with sound. The sound varies depending on how close that fireball is to us, the viewer. And we have the ability to throw those fireballs fairly accurately now. What we're working on at the moment is the ability to now catch that fireball, which is, a step on the way to just juggling them all over the place. Because comedy and fun. So, yeah.
All right.
We're catching.
So if hand.justCaught, like that. Oh, that reminds me, up here, we need to set this to false at the right time. So I think at some point, no. I was expecting to see, because we're creating a new instance of it each time we're okay, it'll be set to false. But we do need to why aren't these initialized to -1? That feels like it should be totally initialized to -1 for both of those. All right. I think that's okay. So if we just caught it, then we need, let's do this at least. Caught. Actually, I don't care about that. We're going to say caught, like this. And I don't care about the vector, compass, direction, any of that. So we're just going to throw that out there. If we caught it, this right here is different. What we need to do is we need to say, hey, if, I don't actually care what the hand's thrown object index is, because I want to be able to catch it in my other hand. So I don't care about that. I think what I want to do is I want to say, are we only checking on the tracking object index? Yeah, is thrown. It's the only thing we're doing here is checking to see if it's greater than or equal to 0. Right there. Tracking object index. So I think what I want to do is it as simple as just saying it's -1? And is it going to reattach itself at that hand? How's it going to know which hand to be at? Oh, wait, I think I know. This dot hand side is the other piece we're holding on to. And that is equal to hand, the hand we just caught it in.
Okay,
dot side, right? There. I think that's the magic.
That seems pretty reasonable, yeah.
Okay. So that also maybe means that this tracking object index, the index we're sending down, I don't actually need it. This thing that I thought I needed, caught object index, no, I don't think I need that. Just caught is true is all I need to do. So let's save that. And Let's get rid of it as well. Here. Okay. Just caught. Yeah, again, right now we're only... Oh, the things I just did, deleting those two, I think those are needed if we're going to support 3 or more, or 2 or more fireballs being thrown at the same time. So we might have to go back and re-add those, but it's not too big of a deal. Let's refresh and see if we can get a catch working. Wouldn't that be nice?
That'd be really cool.
That'd be a good day for me.
Yeah.
All right, there's my overlay refresh. Let's start this up. Start up the app there because that's going to takes a little bit of time to start up. Get the back overlay. Okay. Yeah. Screwchat says, I saw the text stating that Mark's hand was throwing up. I thought maybe it was sick. Okay. Let's turn on the leap. Show my hand position.
Ooh.
World is null. It's okay, Rory. Oh, instances is null. All right, cool. Let's get up here. All right, there we go. All right. Let's see what we got. Okay. Let's move it there. There we go. Better, better, better. Okay. So let's see. Fireball. Throw it up. Throw it up. And uh-oh.
Gravity's gone. Maybe not.
Current position of that object is null.
For a null positioned object, it seems to be very positioned.
I've only got one of these. Current position's not been calculated yet, is my take on this. Update. Let's call it right here. Let's try it there. I just want to see, where is my update? Is there update cat? Check for catch. Where's the update being called? Not from here. That's when the hand data comes in. Okay. All right. So let's do that. Let's do that. And now that works. Okay. So let's try one more time. All right. Throw it up. Throw it up. Throw it up. Okay. It looks like I caught it.
It says caught.
Let me turn off. Let me turn off the show live hand position. So we're just looking at. All right. Up. 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 It's immediately catching it. It seems like. And now it's not throwing it anymore.
It's not being given enough time to, I guess, release escape velocity before you then catch it immediately.
I think there's a problem in terms of the our resetting once we've caught it. I think we're allowed to only catch it once.
Okay.
And now I can't throw it anymore once it's there. Hold on. Where are you? All right. That back one is not turning off. The sound on the back one also is not going off when it should. We need to kind of look at that too. That several times I've noticed that. Thrown object index, throwing is false. How do I catch it? I think it may be down in here. Do I set throwing to false? No, that's coming down from above. The tracking object index, do I set that? I set that to -1 right there.
Well, I guess we need to have an inverse of everything we do when we're throwing, right?
No, I don't. I'm not entirely sure of that actually, but tell me. I'm listening. Go ahead. What do you think?
Well, I just figured we'd follow through. I mean, to be honest, looking at that, there's still only 3 lines of code each, and one of those is to reassign the hand side in case it wasn't the same one. So there's not a lot to be inverting, really.
Yeah. Let's look back up on the top. Get throw vector. Tracking object in the left hand. Ah, here it is. See these?
Yep.
These, when we catch, we need to change.
Right.
Because otherwise, we won't allow a throw. Otherwise.
Yes, because we're not aware that there's an object in that hand that can be thrown.
Oh my gosh, look at this bad code right here. Hands of 0 side is equal to hands left. Well, because I put it in the first hand we find, which could be left or right.
But then it could wind up in the second hand.
Yep. No, it definitely could. Check for catch. So let's look at this.
In fact, arguably, you could wind up with one in each hand.
Here's where I need to make that change. Right in there. So let's do this. Okay. If hand dot side equals hand side dot left, tracking object in the left hand is equal to true. This will get us multiple throws out of here. Otherwise, that. All right, run.
You know, there's not a lot of Twitch streams that could declare that in order to do correct debugging, they first have to throw a fireball into the air and suspend it there.
Yeah. I know. Okay, part of our problem too is we are catching way too soon. We are immediately catching, and I want to stop that. I want to say I can only catch after, like, I don't know, a quarter of a second after the throw. So
it's got to have been a minimum time being thrown.
Yes, exactly. So my virtual 3D object, does it have a throw time?
If it had a launch time, throw time, that would be really handy.
Creation time is what it's got. And creation time is when it's constructed. So all we need to do is check to say, hey, if virtual 3D object dot creation time time now minus that. Looks like we need a breakpoint here. Let's set a breakpoint. Can I get my hand trigger? There it is right there. All right. So now, what, we don't like this. Oh, it's less than, if it's less than time span from seconds 0.25, then we're going to just continue. That's what we're going to do.
Yeah.
Okay, and so let's do that and see if we get better results here with the throw. Okay, throw. There we go. Why didn't I get a catch? I think we need to clamp the Z. That's what I think is the problem. But
oh, okay, because it has now gotten away from you, but it's got away from you in 3 dimensions.
Yes, that's what I'm suggesting.
Such that it's difficult to actually catch.
Oh, man. Or it could be min distance for catch is too low. Let's change that too right there. Let's come in and say, okay. All right, buddy. We're going to say 120. Try that. Clear that. I think we're going to have to clamp down the Z is what I think we're going to have to do. Up and catch. Come on. What?
I fully expect it to stop in your hand each and every time.
Yeah, why is that not working?
That's that realism at play for you, by the way. That's what that is.
That's what I'm saying. That's what I'm talking about, Roy. It's like, it's not quite reality yet. Palm position 3D minus the current position. There's my distance dot magnitude. What is it? I guess we're going to come down in here and look at that. Well, that's giant. Okay. I guess maybe, well, we were catching before, though. We did find a catch before.
Yeah.
I think it's my sense is it's the Z. I think it's the Z is what I think it is.
Yeah, I think that's plausible
That
because it's hard to judge the Z that's actually changed. Although we are scaling,
yeah.
who can remember what it was like a tenth of a second ago relative to what it is now?
Yeah. Let's do this instead. Let's create a float here that's going to be our magnitude, our XY magnitude. Let's do that. We'll call her XY magnitude, or magnitude XY, something like that. Magnitude XY, and we're going to set that equal to distance dot x times distance dot x plus all of this. Let me just use duplicate selection to get me to there and there. And let's select all of that and embed it in that. And we want to do math.square root on that. So we're going to use Pythagorean's theorem, but we're just going to do it on the x and the y. Maybe typecast that to a float. Is that my problem? All right. So that's what we're going to do. It's still a big giant number for right now because I don't have any hands on screen maybe. Or maybe because the ball is so far away. I'm not sure what's going on with that world object. Hold on a second. How many instances do we have? We do not have anything that's checking to see, like, where are these guys? We need to get rid of them if their current position is too crazy out there.
Right. Is this because of previous throws that we're just not garbage collecting?
Yeah, we're not garbage collecting them.
Okay.
And so we've got COD instances. I suppose for readability, we're going to call this expired, or out of bounds instances. No, we just need another method is what we need. It's going to be remove old instances or out of bounds instances. You know what? You can figure out what's going on with the world these days.
The world is a crazy place.
Okay, remove out of bounds instances. I don't need any hands coming into it. Let's rename this to instances to remove. Like that. All right. And we're going to go through all of this and we're going to say, hey, if dot x is greater than max x, I guess, for lack of better term, let's come up here, do the same thing up here, max x. So my max x is going to be, I don't know, about, I'll say 1,000. And that's like a meter out in front of this. And or off to the left, rather. My min x is going to be negative 1,000. Let's duplicate both of those, and we're going to get to a max y and a min y. And duplicate those and get a maxine min z. Okay, so we're just going to kind of set that as a bounding box right there. So if it's greater than max x, or it is less than min x. And then I'm just going to select both of those and hit enter or shift enter on that, and Coderush is going to duplicate those for me. I'm going to change this to a y. What is the problem with the x here? Seems to be indicating a problem here, but it's not telling me what it is. Do I have an error list down here? Yeah, okay, I get that, but what's my real problem? It doesn't have an X in it.
Is it capital X or?
Yeah, I'm wondering. It's position, current position, dot.
Right.
X. Okay, that's what it is. Okay, current position, current position, current position, current position,
Now your comparators on the Y are max Y. Oh no, you got that one, yeah. And the max X previous.
Got it.
Should be Y as well. Cool.
Let's see if coders can give me the last line of code here. If I select from here to here, shift enter. There you go. It's great.
Looks good.
So you're Minzy. Okay, good job. And of course, the invaluable StackOverflow.com, of course. Fried LOLs out there. There you go. Recommend websites, Discord for beginner in programming, first noob steps. Yeah, definitely Stack Overflow for sure. Freecodecamp.org. I love that. I haven't heard of that.
Not heard of that one.
Okay, so current position dot x is so if we're out of bounds, then all we need to do is come in here and say instances to remove dot add virtual 3D object, and then down here we can say, hey, if instances.remove.count is greater than 0, then we're going to go here. We can throw a breakpoint there to see if we ever hit that. We should, with gravity and everything working the way we're expecting it to. We don't need this. And then we do need to call this like maybe about here. Like that. Okay? All right.
Yeah.
I'm not sure if I think we've killed Signal R at this point. I'm going to have to restart it. Looks like
So
we
this
already
now means
got.
that by the time we are catching an item, there will be only one item. Any previous ones we've attempted on any previous iterations should now have been eradicated by the code we've just written.
That is, I would agree with that. All right, looks like they were still working here, which means Signal R is still going. Let's get a fireball and let's throw it up. Okay, what do we got here? Object reference cannot set to null. Yeah, because current position is null. I'm going to have to call update. Or maybe I'll just say... I'm going to just continue, I think is what I'm going to do. Because we just haven't, not enough time's passed. And then I'll say continue, like that. We got one instance to remove, apparently. Let's try one more time. Fireball. Why don't I see you, Fireball? Oh, it got to the other hand. The second hand, which is like, sometimes that gets in view of the leap motion. So I gotta kind of push it out of the way. Fireball. Okay, throw up. Throw. Why no catch? Why no catch? I know. Oh, here. This is why. We need to fix that. Can I get anything in here? I just got to throw again. Let's do it again. Okay. We need to compare this instead of magnitude. So that essentially eliminates the z, is what it does from the equation. And I guess I can set a breakpoint here. See if we ever get in there. Because that's also part of the catch, right?
Mm-hmm.
All right. Fireball. Fireball, where are you? Where are you, Fireball? What's happened? Oh, we got the breakpoint.
Oh.
Okay, so we got catching. This looks like it might be happening. Okay, so Fireball, throw it. Where's my catch? Where's my catch? It's not coming down. Oh.
You threw it off and could have exceeded max and therefore garbage collected.
Yep. If we set a breakpoint
Interestingly,
here,
we maybe don't care about going max Y because gravity should bring it down again.
yes, you're absolutely right. Let's forget about max Y.
Is it max Y or min Y? I don't know which way your origin is based.
It's max. It's max. So I am going to get rid of this line of code right here. That's what I'm going to kill. I need to set a breakpoint, I think, for it. All right. Give me a fireball. I'm going to hit run. Give me a fireball. There we go. Throw it. All right. Let's get rid of that. And keep going. All right, one more time. Fireball. That was wild. All right.
That was a little bit.
I got a throw out of nowhere? What?
Okay, that's all a bit mad.
What's going on, man? Hold on. I think my catch code may not be working so well. Yesterday I did easy task, and today I also did a single task from a book. Do not get frustrated and don't get discouraged. I love it.
Good strategy.
All right, here we go. Throw. 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 Give me catch. Ah! Throw. Give me catch. Oh, why didn't that catch? Let's try again. Give me. Oh, I can't quite. All right.
Right, but we're talking a distance of, was it 12 centimeters?
I'm not sure.
Accuracy.
I don't know what's going on. Hold on. Why
You've got
do I have two fireballs here? Try again. Oh, I think I know what the problem is. I think I know what the problem is with our math. So we are collapsing.
Ooh.
We are collapsing. We're collapsing the z-axis, right?
Yes,
But
that's the theory.
But that's not what we should be comparing. We should be comparing the perspective of the camera, right?
Oh,
Because the front is tiny, but it's very close in terms of its distance left to right. The back is vast. It's not a cube
yes.
that we're compressing. That's why the catch
No,
isn't working.
what do they call it? A frustrum. Is that the word?
You've said this before, and I always felt you were just frustrated.
I
That's what
got that
felt like.
from someone else. That wasn't my remembering of things. That was the chat room from maybe a day or two back.
So check for catch. Here's what we really want to do. We want to take these. We want to say, do I have a 2-scaled point? I do. Right there. Now I don't have vector math on a scaled point. But what I can do is I can come up in here and I can say, we can create a new piece for this. This is going to be our palm position. And we're actually going to be using this for all of these. So I want to call this, what'd you say?
I like this. We can have a scale point for the object in the air.
Yeah.
We can have a scale point for our palm, essentially ditching the Z altogether.
It totally ditches it. So we're going to say,
It's great.
So we have that. And then we're not going to have this. We're going to need to come in here and say 2-scaled point as well. Right there. And scaled point, if you're wondering what it is, 2-scaled point, it should just be an extension method. It returns this scaled point, which is an X, Y, and a scale. So the X, Y position, where is it going to be here, and how big is it in space? So we're simulating the Z dimension with this scaled point. So we're going to do that. We're going to create a new variable for this. This is going to be the current position 2D.
Mm-hmm.
And then we're going to say, we're going to come in here and say the magnitude XY is equal to that. Oh, we need the delta here. So we're going to come in here and we're going to say delta X. Dave Churchill is rating with a party of 40.
Raid. Come in, everybody. Join the party.
Come in, kids. Uh-oh. Oh, no. It's party 3.
Such a tasteful party.
You're welcome. I don't know what's going on. Whoops, what happened? Oh no. Hold on, let me hit a button over here. That was the wrong button. I'm not sure what I hit. Hit some sort of magic button over there. All right, so we're going to say delta X. That's equal to palm position 2D.X minus current position 2D.X. Like there. That's what we're going to do. Right there. Welcome, everybody. We are working. You want to tell them what we're working on for me, Rory, while I write this code?
Absolutely. So we're for those who've never seen this show before, we're writing code to support another show, Dragon Thumpers, as I like to call it, which is going to be a live D&D, or is a live D&D show in which all the monsters, the attacking, the defending, the dice, all of that sort of stuff. In line with that, Mark is basically giving himself the ability to throw fireballs because conjuring things.
That's what I want to do. For conjuring spells, that sort of thing.
Yeah. So we've got the fireball. We've got it on screen. You'll see this in a minute, hopefully. It can be thrown. It can be thrown up, down, left, right, forward, all sorts of stuff there. And what we're working on now is the ability to catch the fireball. So we've released it into the wild. It suffers gravity. It goes up. It comes down. And ideally, Mark catches it again.
Yeah, this is our diagnostic.
Just been trying to figure that out.
This is our oh man, why'd you do that? This is our diagnostic data right here. We're using the Leap Motion device right here to track our motion in space of our fingers. You can see the fingertip positions, and then we're projecting that down onto a two-dimensional plane. Well, kind of not. It's Rory's calling it a frustrum. Is that what you said, Rory?
I think the frustrum is if you imagine the front plane and the back plane, which, as you say, are not the same shape and size.
Small in front.
Those two and the lines that connect them, that three-dimensional space is the frustrum, if I understand correctly.
And so we're taking this data and we are projecting it down onto, based on this camera's perspective of my hands in three-dimensional space. So we're trying to get it, where is everything? Let me turn off our show live hand position. You're with us just in time to see if the catch works. Well, that'll be awesome. Well, that's not good. It's way too high. Hold on. Let's try it again here. Give it to me. There's my fireball. Throw it up.
Hey, success.
Okay, there's a massive Z difference here, right?
Sure.
Where'd it go? All right, I don't know what happened. It's like, okay.
Two out of three ain't bad.
2 out of 3. I wonder if I can throw it from behind. No, we just lost it. Oh, it jumped down below. Throwing and catching. Yeah, I think it's not bad.
You throw from one hand to the other.
Yeah, let's try that. That's a great idea. All right, so here we go. Got 2 hands in here. Oh, man, that was disappointing. Come on, throw. And yeah, my hand goes off screen a little bit, and I got to be really careful on the throw. 3 fails?
I don't know. The second hand thing, I don't know that it's about being off screen because the Leap Motion is still aware of it, even if we can't see it in the view of the camera.
Yeah, well, let's... Yeah, here's the problem, though. Look, as I move over to the right, well, let's see. The palm is not bad. All right, let's see. Where are we? It's not catching it. I wonder if we got some fundamental problem in terms of two-handed catching. I don't think we do. Yeah. Let's try catching just with my left hand. Where are you? Where are you? I'm hearing sound effects, but I'm not.
Yeah.
Like almost to the point that I'm like, wait, what's happening? Yeah, the other effects aren't lining up either. Do I have a bias towards only... Whoa!
Oh, suddenly everything.
What was that? That was crazy.
As you can see, everyone, the algorithm is not perfect just yet.
Oh, it's perfect. All right, here we go. Let's see if I can throw and catch in this hand. I can. Okay. So I caught for a second. And then wait, we're in this state where we're losing the data. The data's not coming in. Oh, there we go.
And suddenly it's back again.
Yeah. I think what's happening is this hand's dropping, and when this hand drops, we're losing something. The hands are maybe switching.
Maybe.
All right, hold on. Okay, fireball. Go. Keep my hand up. Still no catch. Well, we got close, Rory.
Yeah. Well, listen,
close.
we have catching. We have single hand catching.
We do have that. Let's demonstrate that one more time. Although here we go. We've got the data. All right. Throw it. throw it, catch. Throw it, and catch. That's not bad.
That's not bad at all.
Yeah. Throw it. We could constrain it in the Z. Yeah. What I don't understand is why a throw. There's some code problem here.
We've got
Clearly.
some bias towards left versus right, or vice versa, haven't we?
It feels like
Actually, look at it right there. That's the one thing we identified. That's the, trying to. Mind you, no, that is just a decision between left and right, so it can go either way.
Yeah.
That's probably okay as it is there.
Yeah. Part of the problem is we don't have strong certainty that the data that we're getting in from the leap motion device is right every time, right?
Yeah.
Like for example, it could figure out the hand is the wrong one, but then even so, hand up throwing, hand just caught is true. I don't think this is the problem. This is just used internally to see if we're allowed to do a throw or not. This is in the throw call right here. So if the side is left, and if we're not tracking an object in the left hand, we'd return -1. So we can only throw if there's an object in the hand, right? So that's the only that's not the code that's causing this problem. Let's see, set from frame, tracking object. If has trackable effect. Analyze new hand effects.
Well,
that's when we add a new trackable effect.
Hang on
to
a
it.
second. Hold just there. Is that the one I meant to see? That's deciding if there's an object in the left or in the right, based on the first hand.
Yeah, but this is when we get a command in from the Stream Deck that says start a fireball. It is has trackable effect is true, and then we just set it to false, and we just set these. That's the only time that's there.
So it is legitimately okay to do that only in the first hand. Okay, fair enough.
It's like a red herring, this code here. I don't think this is the problem. The check for catch, this is the part that's a little bit weird to me in terms of what's going on. We're getting that position 2D. We're comparing it with the current position.
I mean,
in
we
the
are
hand.
doing a check for catch on both hands, right? That is insider for each outside of here, right?
Yeah. Here we go iterate through
There
all the
we go.
hands. We check for catch on those hands. And I think we've even seen it from left hand to catching in the left hand. So we've seen
That's
that.
true.
I think. Do you recall that? I'm feeling like
I think we
that.
did, because what happened in that one case is you appear to catch it and then throw it rapidly horizontally. So there was definitely interference by that hand, which shouldn't have been possible without a catch and rethrow.
We might change this number. We might change that number. Let's change it to 240. Let's just see, and we can tell it's too big if like objects start jumping and snapping into our hands. Do you know what I mean? All right, let's see if we still have. If we're still seeing data. No. Looks like we may have lost signal R. No, we got it. Why can't I see my hand position here? Our front overlay is not painting on itself. Let me refresh the front overlay. I think I noticed that before as well. There we go. Okay. So front overlay. Yeah, I think we had a problem in the front overlay, Rory. Remember when things, all of a sudden, we'd see them? It was, I think, when maybe my hand moved back and the back plane was showing it and the front plane was not.
Okay.
The front overlay wasn't working. That's why we were hearing the sounds but not seeing it, I think. There was something there.
That would make sense.
All right, so let's try it again. Well, what was that? I don't know what that is. All right. There's a lot of throw. It's like it goes out before it lands. Oh, it's because I'm bringing my hands down. That's a secondary problem too as well. Gotta keep my hand up. And then look what happens. We lose. See what's happening? We're not drawing anything.
So there's the record that it exists, which is why the sound keeps.
Yeah, I think what we need is we need to look at this inside the browser. I think you're going to see an exception, is what you're going to see. Drag front overlay. And that's going to explain why it's not drawing.
Okay.
Let's bring up the console. Let's refresh over here. I'm going to turn off the front overlay on the stream. Bring my hand up.
I tell you what, catching is going to be a lot more difficult in the browser.
Tell me about that. Oh, you just think lining my hand up?
Yeah, because your graphics aren't going to be on the stream at all.
Yeah, that's okay. I'm just looking for the error. Here we go. That's what I need. Cannot read property of position of null. Oh, you know what's happening? We're deleting the object. It's not able to get the object from the index. We're deleting it too soon.
Okay.
So it's remove instances, not there, but here. The problem is here.
So our potential out of bounds box is too small.
Yes. I'm going to change that. So I'm going to change this to yeah, I'm going to do it all the way across the board like this. So we're going to change it to 3000 across the board.
So these are out of bounds for 3D objects, which is to say objects based on leap motion vectors, which are based in millimeters?
Yeah, so 3 meters away kind of thing. So now,
okay.
So let's go back and refresh the front overlay, like that. Come back over here. Get a fireball, throw it. Come on. I'm going to say, I am confident we're hitting this breakpoint here. That's what I think we're doing.
Yeah.
Hold on. Front overlay. I did not refresh the front overlay. Not in a way that would reload that. Well, actually, am I going to get that problem no matter what? I may have to change the code too. Maybe I'll change the code. Code is in Dragon Game on line 1235. Just down from here. I want this. If is thrown, then throw object is thrown object is equal to that. Then if thrown object, then we're going to do that. That's our code. Figure Dev, Six Figure Dev says, how to go to a doctor's appointment. We still throwing fireballs. Yeah, we're trying to catch them. That's what we're trying to do.
We've had some success catching a fireball with the same hand it was thrown from, but we're ideally now going to throw it from one hand to another.
Yeah, my contention is we are throwing the ball's getting out of position. The fireball's getting out of position and we're deleting it because we think it's off screen or something like that. So I'm going to try again here. Why am I not seeing that? Is that one off? It's not showing on the backward plane. I think I need to refresh the back plane, the back overlay. I do, because I made that same code down there in the back. All right, one more time. All right. Give me a fireball. Okay, throw it. Well, that was maybe a miss. We're not getting our breakpoint though. There it is. Okay. That one's maybe
So
okay.
where's the position of that it's decided it's going to get rid of it?
That's a great question. Let's get a fireball, throw one, and just wait. I got to keep my hand. This is the other thing. We said we were going to create a timer. There, now it's out. I'm feeling like that's not bad. Hold on. Let's do it again. Throw it. And now it's out. So it gets far enough down. So I'm okay with that. That's pretty good. Let's run it one more time, and I want to throw it sideways. And I want to see how far to the left. Okay, that's good. So everything's still good. The problem is, here's the problem, Roy, is that I wrote code to kind of accommodate this, but we're not doing anything yet. When I move my hands out, when I come up, I move my hands out. Oh, that was still working. Oh, it must have still be seeing hand data somewhere. Let's try it again. Hands are down. And now we don't see it anymore. It's completely gone.
No.
Because the hand data is not coming in. And so what we need to do, Enceladiosaurus says, these effects are amazing. Okay.
Dave Churchill says, my students aren't going to want to come back to my channel after all these special effects.
I'm sorry about that. Okay. Timer. There's a timer somewhere up in this space. And I need to find that timer.
Speaking of time.
Got to go, Rory?
I'm afraid so, my friend. It's heart-wrenching because I can see, well, firstly, the really quite spectacular level of success that's been achieved so far.
We're getting
You've got
close.
to admit, that ability to catch at all is really good. So this is just sort of like ever so slightly out of reach, if you'll pardon the pun. But I feel like,
Feels
it's
good.
going to be there.
We're almost there.
On track.
We'll see you on
Tuesday?
on Tuesday next
Yep.
week, Rory.
All right, my friend.
I'm back.
See you then.
All right, see you. All right, buddy. Thanks so much. I'm back tomorrow. Thanks, Rory, for your help. Rory was awesome today, helping us out, pair programming with us. I'm back tomorrow. We're doing a beginner-friendly show tomorrow for folks who are learning code. We're working in Unity with C#, and my 10-year-old son is going to be with us. So feel free to join us tomorrow to ask questions, that sort of thing. Here's the thing. I've got an interview. Oh, wait, my interview's later today. I actually maybe have a little bit of time that I can keep pushing this at. Alidus is now following. Thanks for that follow. Appreciate that. I got a little bit more time. So we'll see if we can get this to work with the timer. And I'm just not remembering where I put it. Where did I put that timer? I wrote some code. There it is. Yeah, deal with this later. Okay, so what we need to do is we need to update the trackable. We need to, here, let's set a marker here. I'm feeling like, is there somewhere in here we're sending the data out? Not from here. Here. So when the hands have moved, we send update skeletal data out. We also need to send it out if there's no hand movement at all. In other words, I drop my hands down, they're out of frame. We won't get this event anymore, but we need to update the virtual objects. That's what we need to do. I think I want to move the timer. Is what I want to do. Let's kill the app down and let's move the timer back up into Leap Device. Like that. Let's get our FPS 30. So 30 frames a second, we'll run our timer. Somewhere in our constructor, there it is right there. So timer elapsed. There's our timer elapsed. And then I think what I want to do is store my last update time. So I'm going to come in here and say last update time. It's equal to date time now. We're going to declare this. And then we're going to come down in here in our timer elapsed and we're going to say, hey, if last update time, if date time now minus last update time is greater than, well, total milliseconds is greater than FPS 30, then I want to send an update out, is what I want to do. This sound we don't need anymore. We were just playing this sound whenever we discovered we were throwing. Let's extract this out to its own update data. Like that. Okay, then we're going to call update data from down here. Calling that will reset that last update time. So we're only going to call it if we don't get data in the next, in every 30, whatever this is, 1,000 divided by 30 milliseconds, which is 1,000 divided by 30. I'm bringing up my calculator. It's 33 milliseconds about, 33.33 milliseconds. So if this is more time than 33, more milliseconds have gone by, then since the last update, we're going to call update data. And update data is going to update our virtual objects. Now, fair enough. I could come in here and do this too. I could say if skeletal data dot world instances or has anything like that, I could check to see, do we have any virtual objects? Let's do that. Let's make a check in here. I don't like having the word no in here. I'm going to change this, invert this logic. I say has virtual objects like that. And we're going to say this is not equal to null and world instances count is greater than 0. And this one's going to become if it does not have virtual objects, then the call to update data here is going to say I think I'm just going to come and say, hey, if skeletal data 2D, oh, I still didn't get that all the way correct, did I? Or did I? It's just private, that's all. Okay, public has virtual objects. So if we don't have any virtual objects, then we can get out. And I'm just going to let the timer keep going. I could turn the timer on and off as we went from some number of virtual objects to none. Let's put that in as a to-do. Okay, and I think that's going to solve the problem for when the hands go off screen. Let's try it. Set a breakpoint here, make sure we're hitting it. Yeah. Okay. Oops, hold on. Let's see if I can stop that. Build, cancel, control break. Nope, didn't do it. I just want to delete this guy right here. All right, starting up. Let's close that scroll. Come in here, turn it on. How are we done? All right, good, good. Let's move this off to the side. Let's bring up a fireball. All right, so I'm gonna throw it up and I move my hand out. Oh, that should have kept going. I have maybe another idea on what it could be. We set from frame here. We're going to have no hands at some point when the last time this data comes down. It shouldn't affect the things that are moving, but I'm wondering if the code below has problems. I almost want to come back in here and refresh this to see if we have anything coming up in here when that goes away. All right, let's see if we can get a fireball here. Why am I not seeing it on the back one? I see it here, but why am I not seeing it up there? I wonder if it thinks it's drawing on the back plane. Let's try it again. Got to switch over. It's clearly on the back plane. Oh, because on my hand, that's why. I wasn't seeing it because my hand was facing backwards. All right, so let's try again. Throw it up. Hands are out of the frame. It just goes away completely. I think I have a sense of what that is. Because we're actually hearing it. We're getting into here. Destroy all fireballs. Which is the Y position of, we've got a thrown object. If is thrown is equal to hand following data dot tracking object index is greater than 0. That's true. Get thrown object from index. That should be there. Position should be good. Get hand position from side. I feel like we're getting into this line of code, even though we've got a thrown object, not this one. Because we're calling destroy all fireballs, and I can tell because I'm hearing this sound effect when it goes. When we do that, we kill all of these. So we're definitely calling destroy all fireballs. And you can also call it from this thing called kill hand effects, but I don't think we're actually sending this data out anywhere. We can comment this out for now to verify that. refresh one more time. Let's try throw. Hands out. Yeah, so it's definitely being called from the other place. Destroy all fireballs is being called from here when my hand gets out of bounds. Get thrown object. I think, so my theory is this, is we're really kind of only using, it's kind of like we got a global in here. It's one fireball object. We don't have support for multiple fireballs yet. And my sense is, well, we're getting this. We're checking to see what hand side it's from. The tracking index, the hand following data, that's inside the sprite itself. This should still be good. Get thrown object from index. Copperbeardy is back. Welcome, Copperbeardy. Are you still ignoring Y values because of gravity? That one if statement had if the position is greater than 1480. That's just like going off screen. I don't think that's the problem. But I'll take a look at it in a second. Screech Rat. If we don't have any thrown objects or the length is 0, we get out. We go through all the thrown objects. We check to see if the index is equal to it, and then we return that thrown object. Yes, as if the thrown object is getting removed. Do we have a breakpoint up back up on our one that removes? We call it what? Remove all? Nope. I feel like it might be here still. Let's see if we can get another fireball and trigger that breakpoint. Nope, that one kept going. Okay, run. Let's kill this second. Let's do a lock on instances here. Okay. So I'm locking all these instances so we don't have this issue where we're modifying one and another in two different threads that are essentially running at the same time. Okay, that's all of those. Do we still got my breakpoint in remove instances there? I do. Hold on. It's not my problem. If world.instances equals null, then return false. Otherwise, it's not letting me come in and set this next statement. So I'm going to just kill the app and restart it. I'm not into all these world.instances references inside of my skeletal data. It's a code smell that, you know, things need to get pushed down into world, I think. Okay. I smell deadlock in the makings. Tell me, Coding Gorilla, what do I do, man? I've got those locks on it. I think we're okay. I think we're okay. All right, show live hand position. There, it's on right there. So there's my hand position. Moving around. Here's a fireball. Throw it. Hand down. We did not hit the breakpoint. Well, we hit it now, but we didn't hit it first. So we remove it after it goes down. So that breakpoint's actually good. We're not clearing out those instances, it seems. I think I got to step away from the code is what I think I got to do. I think we'll give you a, we'll do a raid, get you going to somebody else out there in the beautiful live coder Steam world. Folks that are out there. Let's send you over to, I don't know, send you to Vape Juice Jordan. Get you over there. Vape Juice Jordan's a pretty smart, brilliant guy. Codes very quickly. I'm a huge fan. Say hi to him for me. See you kids tomorrow.